for some reason, yeah, I don't know. I mean, I just arrived today, so hopefully this new setup will handle all of this. Alright, so I should be streaming to YouTube now as well. I think so. Let's just give me guys 1 second. I just want to see how do I go to my YouTube thing. Here we go. Thank you very much, buddy. Thanks a lot, man. Let me just put this laptop on which I'm gonna read the chat. Here, maybe somewhere. I need to just, yeah, I need to set up this thing now. Give me 2 seconds here. Let me maybe do something like this so this computer can be there. So yeah, so you guys should be able to hear me really well. I've kind of, once we arrived today, right, I set up this mic in front of my mouth, as you can see, and I have a boom arm, so I bought the whole thing, and I'm gonna leave it here, so when we travel to my remote office in the Balkans, I can just have, so you should be able to hear me as good almost as you generally can when I'm, right, very good sound quality, okay. Because I bought the same boom arm, I bought this Rode boom arm that I also have in Copenhagen. I just bought this thing used for only 100 euros. I'm actually very tired. I mean, I honestly wouldn't have even streamed today. I just promised to you guys, and I didn't wanna not do it, right? So otherwise, we traveled for 12 hours, man. Like we went to metro at 6 a.m. and we came here at 6 p.m. So it's been a long day, but yeah, I just took a 20 minutes nap. I just wanted to, yeah, I promised, so, you know, it's kind of not great when you promise and you don't stick to it, right? All right, that's, yeah, of course, you have to, right? Okay, so you guys can hear me well, that's good. I can hopefully, I'm just gonna check on YouTube if I'm streaming there as well. And then if so, we can start. As you can see, I don't have multiple screens here, so my OBS is here. Don't promise next time. I mean, that certainly would not be, it's not a bad advice, I can tell you that much. Okay, give me a second. So how do I check my YouTube thing? Give me just 2 seconds and we start some Golang again. We're gonna continue our Golang journey today. Okay, so what did I want to do? So I guess if I go to my channel here, yeah, I can see that. Let me just see if I can hear anything. Is there audio on YouTube? Can somebody check? Is there audio on YouTube, please? I guess I can send the Londid, good evening, buddy. Can you hear me on YouTube? If you guys can just see if there's actual audio on YouTube. Here's the YouTube, and then we start hacking. All right, and is it fine quality-wise as well? It should be the same. I miss you. Okay, that's the. Welcome to Bosnia. There's my best man. See you tomorrow, man. My wife is already asleep. Our kid, exactly. So there's no music on YouTube. That's intentional, because unfortunately, so if Leo, if you remember, YouTube doesn't have this this VOD track like Twitch has, right? So you're not able to stream music to YouTube and then not have the audio in YouTube video. So what I did is I configured. So actually, I can show you how I fixed this stuff, right? So as you can see here, I'll just do this before we start coding today, right? So as you can see here, I'm using this OBS plugin. It's an open source plugin for streaming, and you can see that for YouTube, I'm only giving it the audio track number 6. So I'm only audio that's YouTube getting from my OBS is audio track 6. And then if we go here to audio interfaces and stuff, you can see that the 6 really is not sending the desktop audio. So really the 6 is getting only my mic, right? And that was the way to fix, so we don't have to listen to shitty music all the time, right? All right, cool guys. Well, good to see everybody. I mean, thank you for coming as always. I'm in the Balkans right now. We just arrived maybe around 3 hours ago, and then we had some family already here to meet us. My wife's sister, her kids, and la la la. My son now went to sleep already at her grandma, and my wife is asleep. And I'm a being nerd. I'm being nerd as I am. I'm here streaming. Okay. So what are we gonna do today? We're gonna continue our Golang journey. I was kinda before the stream just checking where we stopped last time I streamed, and we stopped at pointers. And I promise you that obviously the series of these streams is not gonna be bottom up as it is right now, because this is it's very university-like way to learn things. But I don't know what people know and what people don't know. So I think familiarizing ourselves with some concepts before we use them is not a terrible idea, but also we need to be careful not to go too much with this, because we can also just as well build things and then go backwards, figuring out what these things are, right? So if you remember last time when we spoke, when I streamed last time, right? Let's just zoom in here. So last time when we spoke, what did we learn? We learned about how to install Golang and how to install the Go tools in VS Code, the extensions, or to say a single extension. And then we said, every Go file has a main file called main. We didn't get to packages yet. We didn't get to a lot of things. We will get to that. But essentially, what we learned were like some types, what they are. We learned how to write, some basic things, statements, loops, functions, etc. And you can all find that video on YouTube already. I've seen actually that people have some people have actually, believe it or not, watched that stream. If I show you, if I go here to live, so people did watch my last stream for like 23 hours. So for sure, some people have watched it. So that was the first stream. So if you're wondering where was the first stream, you can find it on YouTube under live. Some people have watched it, right? All right, cool. Well, anyway, so what we're gonna do today, we're gonna continue where we stopped. Yeah, YouTube is actually growing. I mean, honestly, I'm very happy. So I think we're gonna invest some time. I'm already preparing a small new video called Clean Architecture with TypeScript and Fastify. I already spent a day yesterday creating a repository, etc., etc., etc. Why do you want to learn Golang? Well, I know Golang a little bit already. We use it at work, and I've been dealing with Golang for several years now in almost every workspace I worked in Denmark. Because Golang is a beautiful language. Golang is a very nice language. It's a beautiful language. It's a language that everybody should learn, I think. It's a language that should be a framework or boilerplate for many other languages. It's really a language that a lot of other languages could learn a thing or two about: simplicity, about community, about idioms, and about idiomatic ways of doing things, right? So I think it's a great language. And it's also something that, I mean, I will probably write most of my further services in Go, simply because, Go might not be as productive maybe to build certain things in Go as maybe it is with JavaScript, because of the ecosystem of JavaScript and libraries and stuff. But I think Go is a great language because it's very native to Kubernetes, it's very native to the cloud, it's very native to operating system themselves. It's very easy to run Go binary, unlike nodejs, where you have to, do a lot of stuff. Usually transpile it and do various types of things. With Go, it's a lot simpler than that. It compiles to all operating systems very easily. And again, it's a great... Hi, Alexander. I just wanted to say I loved your YouTube video, Influencer. Thank you very much, man. That video came from my heart. Have you fiddled with Rust? No, I mean, I don't care much about Rust, because Rust isn't a language that I can utilize for anything. So I would have obviously tried Rust. I tried Rust I think I tried Rust maybe 6 years ago or 7 years ago with my colleague Elvis when I was at Airtame. Rust, there was a first book released on Rust. It was called, I believe, Rust Programming Language. So I did play with it back then. The biggest problem, right? There's nothing I can use Rust for. I mean, I'm not gonna use Rust to build an API, right? So Rust is an embedded programming language, right? It's a low-level programming language. So things that I do are not really what Rust solves, right? I'm a full stack engineer who builds APIs and services and client front ends and stuff like that, right? So I think we're probably gonna have next 5 or 10 streams about Go, because I want to learn some of the things better myself. I wanna but also more importantly, we're gonna do some API, some bigger project together. This time it's gonna be open source, unlike Programmer.network platform that we're building. So yeah, I think we're gonna stick a little bit to Go, and I wanted to do this for a long time, to be very honest with you. This stream is going to be a very good excuse for me to use Go more, because I learned Go, if I may be a little bit an asshole, so many times in the past, maybe 6, 7, 8 years ago even. The biggest problem is after that learning would end and I would build something, I would just not use it anymore. So the plan right now for me is we're going to use Go for Programmer Network for certain things. We're going to use it with Cloudflare. We're going to use it for some serverless stuff. But also I'm going to use it at Dream Data. Dream Data, where I currently work, our whole infrastructure is using Go. All of our sources, destinations, everything is written in Go. So for me, this is a win-win situation. And also it's really fun. It will be something huge. Well, I mean, what is huge, right? I wanted to record the video on complexity, right? Because I often hear these comments like, enterprise grade application. Actually, have you ever wondered if you ever read any books, if you read Clean Architecture, Clean Code, Pragmatic Programmer, or if you have ever read anything, there's always this concept, right, like of enterprise application, huge application, right? But what is that? I mean, it's actually quite an interesting subject, because there's always this arbitrary, holistic, abstract thing, right? Well, CRUD literally runs the internet, right? I mean, I'm with you, right? I'm with you in a sense that, yeah, simple CRUD might not be super fun, but I mean, fundamentally, right, the whole internet runs on CRUD, right? I mean, most websites where you go to, you get some shit, you update it, you create it, so you get what I mean. But I get what you mean, right? It's just actually a very good subject for a video, because I was reading some Clean Architecture last night from Uncle Bob, and I keep hearing the word complex, enterprise grade application, complex application. But what is that, right? I mean, nobody can define that, because what is complex? What is big? What is a big application, right? Because all of that can be simplified. Every application can be simplified or overcomplicated, right? In some sense. So I think I'm gonna record a video on that. Just share some of my thoughts, because people are often gonna say this is an enterprise. Well, everything is an enterprise, right? Even when you're in a startup, right? You're not writing code that nobody uses, right? So technically, what does it mean? Enterprise, right? I mean. yes, those streams are already saved on YouTube. Like, you can go to my YouTube channel, and you can go to live here, so you can see the previous time. Last time that I streamed was 3 days ago, maybe. Yeah, 3 days ago I streamed, as you can see. So this was the first version of this stream. But absolutely, we're gonna try to do something fun, right? I'm not, I'm not a guy who is the best at, let's say, algorithms, data structures. I mean, I was really good at that after my university and in my school. So I'm for sure not going to be doing like, a lead code with Go and stuff. Not because I kind of suck at it. In some sense, I do, I must admit. But furthermore, I'm a pragmatic programmer. So I don't solve some arbitrary big O notation crap. I like to build things. So no matter what we do, we're going to try to build something. That's what I like, right? So Yeah, some sort of microservice for sure. We're gonna try to build something like that. Exactly. All right. Well. Actually, anyway, that's great, guys. Good to be back here. Let's continue a little bit, right? So last time when we spoke about Go, right? And keep in mind, like, so just for the context for those of you who are maybe new, so what I'm gonna do with each concept we stumble. That's what I did in the first stream when it comes to this. What I'm actually going to do is I'm going to always compare things to JavaScript, right? So you could almost think about this next couple of streams like Go for JavaScript developers, right? So I'm gonna try to take the concepts that some of you already know, and I'm gonna try to compare them. So now when we actually start talking about the pointers, we're gonna compare what a pointer might be in JavaScript, right? So make the music more loud. Okay. I think should be fine now. Let me know. Is this not? Hopefully it's not too loud. Okay. So basically, as I said before in the first video, right? So we're gonna use VS Code, and we're just gonna start simple. We're not gonna be building anything until. So we will do a little bit bottom-up approach of learning here, just to cover some concepts. Yeah, we do have Discord. I think if you type Discord or something like that, I think if we do this, right? Okay, sorry, there's somebody on YouTube writing. Let me just read. Hello, I just saw your previous video, and here I'm in the live. I have an up and running SaaS written in Node.js, Express, and React, and I have been thinking to migrate the backend to Go. However, you mentioned the previous stream, your software should be written. So I mean, why? So let's just answer this question before we continue. So I mean, you shouldn't ever rewrite anything in any language unless you have a good reason for it, right? So this stream that we're gonna do, a couple of streams on Go, is by no means there to invalidate Node.js. I love Node.js. Node.js is a beautiful way to build simple APIs and system level stuff as well. So I would be very reluctant to just rewrite things for the sake of it, right? Node.js, probably for your case, I don't know if you have any users, is going to be more than enough. And Node.js can scale really well. Only thing that doesn't really scale in Node.js is memory, right? So you would have to lift your memory store to, like, let's say Redis and stuff. So your cluster in your Node.js, because Node.js is single-threaded, so you can kind of your nodes can share the same cache, for example, right? But apart from that, you can very easily scale Node.js. Node.js, of course, uses a lot more memory, let's say, than obviously Go does, because Node.js is fully garbage collected. Go is kind of as well, but it's also very memory efficient. But if this is not an issue for you, if you don't care about saving some memory, which you probably shouldn't care, you should just go with Node.js. There's this stream is not to invalidate Node by no means. Node.js is amazing, and it's very productive to write Node.js. In fact, it's probably the quickest language out there that you can use to build APIs or really anything very efficiently. Because community of JavaScript is huge, way greater than, way larger than Go, not to mention Rust and this new stuff. I mean, it's uncomparable, right? So you should for sure continue using Node.js, right? But Go has its applications and uses, and of course, if you have already built your API in Node.js, then you should continue using Node.js. I mean, again, you should be pragmatic and always ask why instead of blindly, right? Doing something for the sake, because again, I have a video that I recorded on YouTube. It's called Influencer-Driven Development Programming Propaganda. So I don't want you to use this stream to be influenced in a bad way. This stream is never going to suggest you to do something that's not pragmatic. I'm a very pragmatic person, so try to build products and focus on building products, not building code, because no matter what you build your product in, for the most 99.9% of websites is going to work. You can use PHP, Ruby, Java, C#, whatever you use. It's not going to make a difference for most people, right? Actually, I did chica, man. As soon as we landed to Belgrade. We drew to some barbecue place, man. I ate so much. I'm sick, man. Okay, guys. So, but good question. Let's just continue. Okay. So now we're gonna speak about pointers. So we're gonna continue our Go journey, and we're gonna speak about pointers. And yeah, the pointers are very simple and very complex at the same time. I remember when I was at university, maybe 15 years ago, I remember that many students struggled with pointers, right? Because of the way that pointers are taught, right? But let's just talk about pointers before we read this documentation. So yeah, a pointer basically is a variable that points to an address of another variable, right? But what does that even mean? Why do we even care about that? Why would we want to create a variable that points to another variable, right? Doesn't make much sense, right? And if you're coming from dynamic programming languages, this can even make less sense, because in dynamic languages you're just passing, into JavaScript for example, you're just passing mostly references around. If you're working with objects and arrays, if you ever pass that array or an object to a function, you're essentially passing a pointer, right? And because there are no pointers directly in JavaScript, right, then it becomes a little bit complicated for people to wrap their head around. It's like, what is a pointer, right? So basically, let's just compare this in theory a little bit, then we're gonna write code, right? So in JavaScript, as we discussed last time, we have idioms in JavaScript, almost like JavaScript should be written in an immutable way, meaning every function, no matter what it gets, a primitive value or a referenced value like object, should always return a new value, right? And that's why JavaScript memory-wise isn't very efficient, because we keep copying objects. We just copy everything. So you call a function that does something and it returns a completely new object, new data structure, right? So this is how we write JavaScript. In JavaScript, we don't want to mutate things there's a huge benefit of this, of course. So this is not to say it's negative. When you write immutable code, you write code that's easier to debug. It has less side effects. It's easier to do so many things, right? But the side effect of this is memory, right? So every time you copy an object, you essentially create more memory, right? In Golang, right, and languages like C, C++, and various strictly typed languages, we have pointers, and pointers basically allow us to mutate things, right? Just as we can do in JavaScript as well. I'm going to show you. So there's no difference, right? In JavaScript, we can also mutate values directly. Of course, you pass an object to a function. If you change that object in that function, well, you're going to mutate the original object. But the fact that we don't do that is because we want to return new things. So let's talk a little bit about this, right? So if we go to JSBin or whatever, if I actually even use if I just use the console, right? So let's use the console. And now we're talking about pointers, believe it or not. So it doesn't matter if we're in the JavaScript world, JavaScript has pointers as well, right? So if I have an object here, if I have an object here called person, and then person has a name of John. So this is a reference type now. So objects are reference type. They're not primitive values. So this thing now is a complex type, if we may, right? So if I create a new function now, let's just create an actual function. Let's say function change name, and let's imagine this function takes a person, right? And because we don't have types in JavaScript, we're writing JavaScript now. Let's imagine this person also is a type, right? So, but let's say it takes something called p, and then here we can say p.name, and we can just create this function with a additional name, right? So say p_name, and so now if I go ahead and I say change name, and I say a person, and name whatever foo. Now we're going to mutate the original person. So if I print this person here, you can see that this person now has a name of foo, right? So, and why is that? Well, because we literally take the person here as an argument, we directly mutate its name, and then as you can see, we have mutated original object, right? So you can see here when we pass p, basically as this, we don't have an ability in JavaScript to pass it as a value. We can't, there's no way to tell the function argument list, hey, I don't want to pass this person as a pointer, I want to pass it as a value, right? We don't have that ability in JavaScript. Every time you pass any complex type in JavaScript to a function, let's say, you're passing a pointer, a reference to that object in memory, right? So that's why very often in JavaScript, right, you're going to see that when we do this, right, what we do, we say something like, const copy of p, and then we do the spread operator or object assign, right? So, you know, or object assign. And then now here you could, if you said copy of p is name, I mean, we can do this synthetically in many ways, right? We can also say copy of p, and here we can say name, or we can just literally return, right, something like this, right? So now this is why in JavaScript you often see the spread operator or the object assign function method, because yeah, because we can't pass an object as a value. We can only pass it as a reference. So that's why often we just take this object, we make a copy of it, then we change the name, and then we return the new entire object of it, right? So that is basically the difference, right? So doing it this way, you're gonna mutate the original object because again, p is a pointer here. But here, if we make a copy of the object and then update the name, then we're not changing this person here, right? So if I actually copy this and just refresh this, so this all the global stuff we defined is gone. Let's shit. I don't think that I saved it, did I? That's why I should have written it there. And give me a second, I'm turning on my other laptop here just so I can read the chat. One moment. Shit. What is this crap? Turning my MacBook Pro here just so I can read the chat. Let me see if there's actually any messages. All right, so again, so just to recap this, right? So as you saw in JavaScript, right, because we can't pass a complex type as a value, it's always a reference, right? We basically, so let's just write that once again. So I have a const, let's say person. This person has a name, let's say foo. And then, as I said, yeah, we had const change name. It takes a person and a new name. And then if we did person.name is this new name. If we do, you know, change name and we pass this person object and a new name, Baz, right? We'll notice that the person has been changed. So just to recap this once more, then we move to Go. And we're missing some, yeah, we're missing lambda syntax here. So we try this again. So you can see we have changed the name foo to Baz because here we directly mutate. But if we, as we do very often in JavaScript, if we did this, hey, spread the person, meaning make the copy of the person that we're passing in, and then do the name, right, like this. Then, and this is just JS thing is complaining about it because it doesn't. You can see now that we no longer mutate the original object because this function now returns a new one. So if we truly wanted to mutate this directly, we would have to say, you know, something like this. Person.name is, or actually just we would have to directly, we could just say .name, right? And then if we get over here, you can see now the object is Baz. Give me 1 second, just to, I can't read the chat. Where's my, Jesus Christ, come on. Dream date. All right, so now we're gonna go to Go. So yeah, so in Go, if we actually grab this stuff and just copy it to my, why don't we want to mutate the original object? Okay, it's a good question. Why don't we want to mutate the original object? Well, that's the thing, right? So we don't want to mutate the original object, and we want to write immutable code because immutable code is easier to debug. It's easier to reason about. It's easier to it has less side effects, right? Because as you go in your code and you have bunch of functions operating on the same data input, right? Then it gets very difficult to see where this data input changes, right? So that's the whole point of immutability in functional programming is that your initial data structure, your initial value is once it's once it's declared, it's immutable. It becomes so what you always know that in this context here that this person would never change. The functions that utilize this data would return a new value, but the original data would never change. And that gives you the benefit of having an easier time reasoning about your code and seeing, so now instead of needing to follow through the whole, let's say, stack trace of, okay, who changed my person, you can now focus on individual functions and what these functions do, right? So that is the premise. Yeah, exactly. So let me just open up my Twitch here on the laptop again. I'm sorry for that. It's just my Mac OS restarted because I had to do an update. So that is basically the premise of it, right? So that's why. So but again, keep in mind, it's not one or the other. This is not a yes or no type of thing. Both paradigms have obviously positives and negatives, right? The negative paradigm of this thing, right, is that we're creating objects all the time. And this obviously, let's imagine we're talking about embedded programming. Let's imagine you're working on a PCB that has 256 of some SDRAM or DDR1 or 2, whatever, right? So you're limited by the constraints of hardware. So you don't have 32 gigs of RAM, 64 gigs of RAM. So your browser cannot just consume 3 gigs of RAM. That's why when you open your Chrome in your activity bar, that's why your Chrome takes 3 gigs of RAM, because websites don't really care about your memory, right? And that's maybe fine, but when you're building apps, let's say with languages like C or Go, you generally do care about these things. You care about when you initialize, when you declare your things, and then when you initialize them, right? So, so there's, again, this is not to say that one wins against the other, but there's positives and negatives about both of them, right? So it's not that simple. Yeah, so if we copy this thing to our Go program and we just run Go run main Go in here, right? So we can maybe just for this session today, I'm gonna move this panel to the right so we can use the console. We will not be really. I don't think this stream we're gonna get to the point of actually building a full-scale project. We're still gonna go. So if we can kind of go through this here, right? Yeah, so as you can see here, if you remember, we're using this, the example is using this shorthand way of assigning values in Go, and you can really only do this if you remember inside of a function. You can't use the syntax outside of the function scope. So let's kind of try to decipher this, because I'm sure that it's confusing to people who never, let's say, use pointers in a strictly typed language, right? So if you're coming from Ruby or Python or JavaScript, this might not be super clear to you, right? Does memory efficiency matter on server side? If not, why would someone switch over using Golang instead of JavaScript? Well, I think it's a very good question, Altan. I think it's a very valid question, and this question, that's why I recorded the video, influencer-driven development programming propaganda, is that this is not there's no absolute answer to this, right? Does memory efficiency matter on server side? It really depends what your server is, because the thing is, we often, when we talk about backend, right, we often only think about CRUD APIs, but backend is far more than just a CRUD API, right? That might be, you might build for example, Go. So for example, if you have ever used PubSub in GCP to send messages, millions of messages a second, if you have ever wanted to build something like RabbitMQ using, let's say, Go and stuff, then it absolutely matters, right? So it really depends on the use case, right? Does it matter? For most people, probably not. So for probably 90x% of people, building a simple, under quote, simple, because what is simple, what is complex, but building a relatively medium business type of application that has few thousands users and stuff, it probably wouldn't matter. Would you say when some resources, let's say on GCP, on AWS, maybe need less memory, less CPU? Probably. Does that translate to less money? Probably. But again, is that money significant? Is your time spent on building software more valuable or less than saving $300 in GCP, right? So it's a very valid question, and I would say pragmatically, and to be very honest with you, probably not, right? So for most people, because again, whenever we hear these performance discussions, performance, what people really talk about, they're using the main use cases of companies like Netflix and Twitch and stuff like that, and then they're laying out or kind of making some assumptions based on, oh, Twitch, oh, this. But I mean, an average developer that works in an average company is never in their lifetime, in their career, build something that needs to serve, I don't know, millions of anything, right, a second or whatever. So it's a very valid question. I would say no, for the most part, if you're pragmatic, Node.js is probably going to be a better in the context of speed of development, community help, libraries, hiring and stuff. It's still a lot cheaper to hire a Node.js developer than it is to hire a Go developer. It's also easier. Community in JavaScript is huge, which is its biggest benefit of JavaScript, is that you can find library for almost anything. Now, is the quality good as Go? Probably not. But again, that is the question. Is that important? What is quality? And what is the quality that you're willing to accept in the context in which you are, right? So if you're a startup that needs to get out there, survive, build a product, right? Right. What have you built in Rust? What have you built in Rust? Did you build a product in Rust that works and serves users? I don't think you did. Okay, so this is basically my response to that. Okay, so let's now get into my pleasure, man. My pleasure. All right, so let's go and talk about a little bit about pointers, right? So so when it comes to pointers, right, you really need to memorize two things, right? You have to memorize this operator and this wildcard operator, right? So as you can see here, and we can just for the simplicity's sake, let's just comment out a few of these things, right? So let's just work with a single value for now, right? Just so we can see a little bit of how this works. So you can see we have a variable, a simple variable, an integer. So we have var I int is 42. So we have a simple integer variable that's number 42, and then we have a variable p. So let's call this banana instead, just so you don't, but you for some reason think that this has to be called p. It doesn't, right? It's usually a practice, but you don't have to call it like that. So if we print this now in VS Code, we're gonna get 42, right? And why are we getting 42? Because what we're saying here is like, hey, create a new variable, a pointer called banana, and give me the value that's at this memory address, right? So basically here we're assigning the memory address of I variable, and then here we're dereferencing it, and then we're getting the value of it. So hey, we're saying, hey, what is, dereference this and give me the value that's there, right? So as you can see here, this is where we say, and let's not actually call it banana, because let's just call it pointer to I, right? Let's just call it like this, right? So pointer to, so actually if we hover here, you can see, it's a very good question, right? So you can see if I hover that, because we're using the shorthand, but you can see that the type is this. So actually if we stop using this, right? So let's just do that, right? So let's just do it like this, so maybe it's clear for people, right? But you can see here that when you using the star, right, you're saying I want to declare a variable that's of type pointer, right? This is an integer pointer. So this thing here says, hey, I want to create a variable, I want to declare a variable of type int that's a pointer. So it's a type of pointer that points to a value that's going to be int. So you can see here you have to say this int to indicate that this is a pointer variable that's pointing to the memory address of a value that's int, right? So that is the and I don't know actually what the fuck is going on here. You get what I mean, right? So you can see here the star just, I mean, this is just imagine that the star was literally called something like PTR. Imagine that this language, instead of implementing star, it just called this PTR instead. It's just a Go has probably taken this either from C or C++ or whatever, so they got inspired. This is not, Go didn't invent this, right? You have the same thing in C++, you have double pointers, weak pointers, etc., right? So here you would just have a pointer like this, right? And this is saying, hey, declare a new variable called pointer to I, and it's going to be a pointer that points to the integer type, to a value that's an integer. And then here it's saying, hey, point to the memory address of that I. So not to the value itself, but to the address where this value is, right? Exactly, Chica, right? And then we print, so we do the dereferencing here. So we say, hey, read what it is at that pointer, right? So you can see read I through the pointer. So we are basically reading the value now of this memory address, right? Right. So this is kind of it. So we have this syntax, we have the star, and then we have this ampersand, right? One is a memory address, another way is to read what's at the memory address. You could think about it that way. So when you see something like this, you're saying, hey, read what's at the memory address of this thing here, right? So it's like the opposite of this, right? This is the memory address. This is pointing now to this memory. Like if we would print the pointer without dereferencing it, right? If we do this, you'll see that we're going to get this, right? And this is the memory address where this variable is. It is Chica, but Go basically hides that from you, right? Because you can do that in Go as well, but it's a very non-idiomatic way, right? Because it's a little bit strange syntax. You can do that in C++ if I remember as well, right? Something like that. So yeah, so you can see here, so if we just print the pointer to I, if we just print the actual pointer, you can see the value of that pointer. And the value of this pointer basically is, it's a memory address. So this is the basically memory address where this value 42 resides, somewhere in the memory block, right? Because memory is separated inside blocks, right? Yeah, okay, so great. And then if we want to say, well, hey, how do I read the actual value that's at this address? Well, then you do the dereferencing, right? So then you say, all right, so I want to actually read what's here. So I don't actually care about the address. I mean, I cannot really use address for anything tangible. This is just a place where the value. Imagine this is like a literal like a sign on the street. And it points where something is, not what's there, but where it is. So you could say that this thing points to where something is, but then when you get there, you have to ask, well, what it is at this location. And this is how you ask, this is say, okay, so this is telling me where the value is, and then this thing is telling me what the value is, right? So that is the difference. Where is the value? It's here. What is the value? Well, then we ask here, right? So there's the difference, right? And then as you can see, if we go to the next line, so if you read this, if you remove this, now here we're doing something else, right? So if we do a pointer to, and as you can see, it's very logical. Here we're now reassigning, we're assigning a new value to a different variable. So this thing here now is more or less identical if we said I is equal to 21, right? But we're doing it through the pointer. So we are, and this might be a little bit confusing and almost in the way that we are learning things together now, it's almost baseless and illogical. It's like, why would I do this? Why would I change the value of 21 through the pointer when I can just say I is equal to 21? In this context, there's no reason, really. This is just to illustrate that's what they're trying to do with this example, that you can in fact change by changing the you can change the value of something through the pointer itself. You're saying, so hey, change this memory address to now point to or change this pointer to point now to a different value, basically to 21, right? So this is the way you can set the values to the pointer, and then if we print the actual I here, you'll see that the I now is 22, right? So we have changed it through the pointer, right? And then as you can see, you can do this is pretty much doing the same shit, right? let's just introduce another variable. Let's say here var k is 2, right? Just to be simple, let's say k is 2. Let's actually, just for the fun of it, let's just say k. Let's just memorize some syntax together, right? So let's just say, just because we did this in the last stream, right? So now we will do something like this, pretty much like that they're doing here. And we actually don't need this. So here we can say pointer to I. And then we can say pointer to I divided by k. And then let me move this to like 40 or whatever. So let's see if we can decipher what's going to be this, right? So what are we doing here, right? So as you can see here, we're doing here something that we just did on this line. On this line here, when we assigned the value to a pointer, right? So here now we're going to say, we're doing the same thing. We're saying assign the value to a pointer to whatever the value of this is when it dereference it, and then divided by k, right? So if we print this as well, right? Again, we're gonna get 10, right? Why are we getting 10? Well, because of all of the things that happened here. So pointer here is 21 now, and then at this point, this is at least what we did. We divide it, and we're gonna get 10. Why are we getting 10 and not a floating point number? This would be a good question, is because, so you can see how the hell are we getting 10 here, because pointer to I is now 21. So now we divide 21 by k. So why are we getting 21? Anyone? Any reason why we're getting 10 here and not 11, or whatever you would expect to get when we divide this? Because obviously it's an integer, right? We have an integer type, so we're gonna get a whole number when we divide this. If this was a floating point number, like float 64 or whatever, then we would get a different result, right? So we could potentially, I guess, say float 64 and then do this. I don't know if we can, in fact, right? Exactly, right? Right? Because it's complaining that, hey, you can't do this, because, hey, this is, in fact, a... but if I did something like this, if I say var j of float 64 is this, right? Then we could basically say here j, and then at least I would expect a different value. And you need to cast the memory address. Okay, exactly. I think you're right. Yes. But either way, that's a little bit different subject now, right? Yeah. But either way, right, you get the point. So you can see. So what is the problem with this bottom up way of learning, right? Is that, where is it? So I'm not really the biggest problem of this thing is that it's not very pragmatic. This is not a use case that would demystify to somebody who hasn't worked with pointers before. So this is the only downside of Go documentation, and I think why it isn't completely amazing. So it's great, but the only downside of this a tour of Go is that it's not very pragmatic. It's very theoretical, right? Like, I remember when I was in university, we studied pointers exactly like this, and then it takes 3 months for you to start using them in some reasonable setting to understand why the hell do I even need this shit, right? Right. We need to cast the value itself. Well, we are basically coercing thing here. We are saying, hey, but maybe this thing here, because this is an integer, right? Maybe this is, so maybe we need to do, is that the case? I don't actually know. But we can't do this because this is an int, right? So this is an integer value, right? And this is also an integer value. So I don't know. I would expect this to work, but it doesn't. So basically, this operation, we need to tell it, hey, you should actually be returning a floating point number, not an integer, right? Oh, maybe exactly. So look, I'm by no means. Let me actually see. I'm by no means. Let me just see. Do I have? Let me just take a look at one thing, because it would be super useful if we had. I think I do have chat here, right? And I have GitHub Copilot. I do. Okay, great. So I don't know why is it not giving us any help. Yeah, exactly. But that's why I'm saying I don't want to do that now, because then we are kind of moving away from the now we're then talking about coercing values and stuff like that. So it doesn't really matter, right? Probably yes, you're right. If we would make this a float, right? But then we have to change the rest of the example, right? So that's why I'm saying it doesn't really matter, right? Oh yeah, and actually it's a good point. So Golang, as you saw in the documentation, doesn't have pointer arithmetics, right? So what does this mean? This means that you can't increment a pointer, right? So in C++, for example, you can increment a pointer. You can loop through some list, and then you can increment the pointer by, let's say, 1, right? And then the pointer is going to go to the next item in memory, right? So in let's say in Go, you can't do that, which makes it a little bit easier, because in C++ it's very common that you use a pointer when you're looping through things, right? Because you're looping through something. So in Go, you can't. There's no, as you said. That's a thank you, Chika. So as you can see, it says unlike C, Go has no pointer arithmetic. So there's you can't do crazy shit in Go with pointers, right? Yeah, exactly. And basically, Go claims that this is obviously a feature of the language itself and not the limitation, and I to some degree agree. And this is where so my experience when I was working with C++ myself many years ago is that C++ went really too far with pointers. C++ went really far. Then I remember in C++ 11 they created a weak pointers, strong pointers, and stuff like that. And right. If you change the k to float, the operation within the... Yeah, I'm fully with you. It's just that I didn't want to go now to casting and stuff, because I just wanted... we should stick to a subject maybe at hand rather than going too deep, maybe, because it... And good evening, my friends. Good evening. Okay, so hopefully, look, just FYI, we are going again very, very bottom up. We will start building things soon in maybe next stream or the stream after. So be patient. All of us should try to get familiar with the syntax, just because once we start building things, it's better that we have some context. It's not that we're going to memorize all of this crap, of course not, but it's good to have some context before we start building, because it's going to be quite a huge jump. We're going to go from knowing very little to building, something, right? The point of a pointer is, as I was saying at the start of the stream, is exactly using less memory, right? So again, if you compare Go and JavaScript, for example, they're very opposite in their paradigms. JavaScript is all about immutability, like Haskell, for example, and functional programming languages, whereas Go is all about efficiency. But of course, efficiency for the sake of complexity, right? So that efficiency doesn't come without price. The price of using pointers all over the place is the price of mutating a lot of things, which means it gets a little bit harder to reason about your software, because of course, and quite opposite. Immutability doesn't come without a price. It's like, oh, let's just copy everything, right? Well, yeah, let's do it, but it has a price as well, and it's very reasonable actually when you think about it, because let's think about it this way, right? You don't really care much about performance in JavaScript. Let's face it, not because JavaScript is a shitty language. It's not. You can, if you want, mutate everything in JavaScript as well. That's the language. That's the default. That's how JavaScript works by default, right? But you cannot compare, right? I mean, Go is a system level language. It's built. It's same when we talk about Rust, C, and stuff. It's uncomparable. You have a different domain, and these languages solve fundamentally different problems. And JavaScript doesn't solve a problem of performance because you're building web pages for the most part, right? Whereas Go, you can use Go to build an API, a CLI tool, a driver. You can build your own language on top of Go, right? So it's they have different they solve different problems, right? So we cannot expect JavaScript, for example, to solve all the problems, right? So that's how I see it, at least. So, but anyway, two paradigms are different. Those two languages focus on completely different things, right? And both paradigms come with a cost. It's just how it is. All right, so structures, right? Structures are very simple. If you have ever worked with what the hell happened? Oh, that's if you have ever worked with a TypeScript or any type system, flow or any really strictly typed language, a structure is just you can think in a JavaScript way, almost like an interface. Not really, but that would be the closest. But you can think about it as defining an object in JavaScript, right? In a way. Let's not use vertex and this math bullshit, right? Because they do this thing almost like a math student is learning a fucking language. So let's just say here, a robot, right? Or I don't know. Let's use a person, right? And let's say name. I hate these examples when they use vectors and shit like that because it's just annoying, man. Just use a fucking human language, man. Not everybody is Jesus Christ, man. And then here we can say name John. So this looks familiar, right? We have a person, and this is an entity, right? So just like an object in JavaScript. In JavaScript, you would say const, person is, again, this is a type, so keep in mind, but I'm just illustrating it, right? So struct basically defines the struct defines data structure of multiple properties, basically, right? So a struct can have properties and methods. In Go, they're called receivers, but again, if you can correlate that to methods in Java, C#, object-oriented JavaScript, then you can do the same here, right? So this can have a person can have a type, and then we can say func say we can do it like this, but we can also create a function receiver like this. We're not going to get into this too much now. We're going to get this at one point sometimes in time, but this would be a function receiver now, and you can also create just a normal function, of course, that takes a p. So you can just say func p person, and this can return person as well, right? Now, and I didn't give the function the name, so let's say func get person, and here we return name just for now, right? Okay, so let's just wait here. So as you can see here, and let's actually write this properly, right? So let's just say here that we return p, just a dummy function, right? So a structure basically defines a structure defines let's say a variable that contains multiple properties. These properties can be primitive or complex types. They can be functions as well. And as you can see here, we have two functions, right? This is just a normal function in Go that takes a value of a person, so not a pointer. So we're gonna talk about this in a second here, and then it returns a person. Now this is a function receiver, right? This takes a person, so this is a little bit different. This is attaching a function to the struct. So the struct now has this thing, right? But we're gonna discuss this later, so let's not go crazy about it, right? So here we have a type person, just like in JavaScript. You can say var, whatever. Person is person. You define it like this, right? And then we can print the person, right? So nothing crazy about it. It's just like an object in many other languages. That's almost really what a struct is. It's just a structure. You can create any type of a structure, right? We're gonna talk about function receivers and stuff like that. That doesn't. Let's see what these guys are saying. I think a struct is a collection of fields. Actually, that's a great one, right? Yeah, actually, we will. So the biggest problem now, right, is that there's so much. So there's two fundamental things I want to get out of these stream series. There are two things. One is the Go itself that we're doing, and two is finding the balance of how to learn new things, right? I think there's so many things, like, for example, we just looked at structs. Is this all that you can talk about structs? Of course not, right? The biggest problem is finding the balance with theory. We shouldn't go too much, right? These first two streams are going to be just familiarizing ourselves with what Go has. And then I can think once we start building things, it's going to get more. Then we're going to do a little bit top-down approach. We're going to build and then go backwards to those terms, right? Because it's too much of this is boring. At one point in time, we have 27 things to go through, right? At one point in time, people are going to get tired. It's like, shit, man. How many of those do we have to go through before we build something, right? HRV, thank you very much, buddy. Likewise, I wish you and your family all the best, man. All the best. Struct fields. There's not much to say here. This is again what we saw. Struct fields are accessed by a dot. So we do the same in JavaScript, right? So what they're saying, person.name is though. So there's really no difference. There's no difference. Thank you, man, as well. So there's really no difference here, right? So it's pretty much the same. So in most languages, really in all languages that I worked with in my life, and I tried many of them, you really access things in two ways. Either this or this, right? So this is generally in Go, this is how you work with maps. We're going to talk about maps. But either way, in JavaScript, for example, both of these ways are valid ways. In JavaScript, we also have dynamic accessors. So this can be an expression that evaluates to a property name, for example. That came with, if I recall, ECMAScript 6 or 7. That was an amazing feature that came to JavaScript. All right, so let's go. Pointers to struct. So now it's getting a little bit spicier, right? So let's read. Struct fields can be accessed through a struct pointer. To access the field x of a struct, when we have a struct pointer p, we could write, and this is basically what Chica wrote, if you remember. Chica wrote something like this, right? But it's going to say, you see, however, that notation is cumbersome, so the language permits us instead to write just p.x without the... And this was the problem with C++ for some time. You would find this is a very common thing you would see in C++, right? I don't know how it is today. It's been many years since I wrote C++, but yeah, this is a very cryptic syntax, right? And it's not easy. It's not a programming language, no matter of how low level it is. This is also the huge problem with Rust. Rust is a very cryptic language. That's not a nice language to write. No matter how efficient or inefficient it is, it's irrelevant. It's not a language that you look at. It's like looking at Lisp or Clojure, right? You look at these languages and nobody ever said, oh my God, this is like just makes all the sense, right? No matter the competence level, you can be the best in these languages. You can be an expert, but when you look at it, and this is what languages, when you design a language, you have to account for. Language can be efficient and it can be great and memory safe, whatever, but the fundamental question is how developer friendly is it, right? How easy it is to look at it and say, okay, well, this makes sense. It's so easy to read, right? It's like you write a book that nobody understands, right? All right, so let's take a look at this. So let's take a look at this example together, right? Because now we're back to pointers, and let's not call this vertex, right? Again, super annoying with these shitty examples, right? Let's just call this name, and we're gonna have string, and here we're gonna have name Alice. And thank you everybody for your follows and stuff. I very much appreciate it. So as you can see, essentially, so as we just spoke about pointers, there isn't much of a difference. There's no specific rules, really. None of the rules that we learned about a couple of minutes ago have changed. Here we create a new pointer called p. It points to the memory address of this person, right? And yeah, that's really all that there is. Now this p is really a pointer, and as you saw, basically what they're saying there, they're saying, well, you can also do something like this, right? But it's very cryptic, right? They're saying so, and then they're saying, well, you know, because we have to. So let's just discuss this, because you can see this documentation is very vague, right? So why would you sometimes in some languages like C++ before, why would you have to write this? Because you have to first dereference this pointer, and then you can access name on it, right? And I actually remember now, going very deep in my head, actually you don't have to do this in C++ either. You can do, in C++ you basically do something like this, right? So this is how you would dereference, right? But either way, if I recall, you guys can correct me. So anyway, in Go, they're saying, well, you actually don't have to write this cryptic stuff. We're going to do that for you, right? You don't have to write this cryptic parentheses, right? We're going to do it for you. So right, because again, fundamentally, language has to be something that motivates you. Programming language should be something that helps you to build things, not to... And this has been a huge problem with C++ for many years in languages like that, is because no matter the performance, no matter what, it always is a battle between being efficient, being easy to approach, being easy for new people. Exactly, Leo, right? So this is, I'm not trying to be an asshole here. All of these languages are amazing. I love C++. It's just, you just have to, we have passed the basement dwellers days of the 80s and 90s and 70s, right? So today, an average developer is going to pick a language that's accessible rather than efficient only, right? So that is the problem, right? Okay, so but anyway, going back to this right now, we can see here that there isn't really a difference. So when it comes to pointers, so far we learned about dereferencing, we learned about assigning a point, creating a pointer, right? And somebody asked, hey, what is the type of the pointer? Well, you can always see that the type is always going to be you have a variable name, and then it's going to be the type of whatever the pointer is pointing to. So you can see here a person. Yeah, pointers are used quite a lot in Go. Yes, they are, especially when you start working with the routers. For example, when you're building an API, then the request and response and all of that stuff is essentially a pointer, right? You have the context and stuff like that. So I would say yes, yeah. All right, cool. So this is the pointers to structures, right? Struct literals. Okay, so let's discuss this. What is this? I don't actually know what it is, so let's see. Struct literals. Okay. And again, let's not use those shitty examples like vertex and stuff. It doesn't help. Let's simplify. So you can see, please, one thing that you can learn from this, no matter what you're learning from, try to simplify things for yourself, right? I'm not going to use a vertex as an example because it makes no sense. I'm going to use something that doesn't furthermore, it doesn't introduce another thing that you have to think about. Oh, what is a vertex? What is a one? Who cares, man? We're not learning math here. We're learning about different concepts. All right, let's just simplify this example. So let's see what we have. So we have a structure called person. And then we create few persons, right? We have, let's actually also furthermore, let's say var person1 person. And I'm a little bit constrained here with my editor. What's going on? There's no really there's no, if you're referring to JavaScript constructors, there's really no such thing in Go. But what is oh shit, I'm sorry. I didn't realize this outer var. Okay. So let's just say here var v1 person, and let's say here var I just want to simplify this a little bit. So person2 person var person3, And as you can see, we don't really need to provide the person type. I'm doing that explicitly just so all of us, as you're following these videos, get used to, right? And what did they have? They had, and then they had just a p at the end, right? So this p basically is a person4. So let's say var person4, person is this, right? And what is this complaining about? Well, let's see. Cannot use person value of the person as a person value. Okay, it's because we didn't give it the right type, right? We need to make it a pointer type, right? And that's why I want to write this explicit, so it's not hiding, so it's not really hiding the types, right? So, and this lesson is called what? Struct literals. Yeah, struct literal. Yeah. So this is basically about initializing certain things, right? So a person here has a type of person. Now, since we have changed this example a little bit, let's just say here last name, and let's say string as well. And I keep getting back to JavaScript, right? And actually, I don't like this syntax at all. So let's just say here name bar and last name Bass. And we're missing a comma. Jesus Christ, man. Okay. Okay, so let's and let me maybe put this terminal down there. It's a little bit it's a little bit getting in my way. So panel position, no, align panel, panel position bottom left. Now let's just make it to panel position bottom. Okay. So what do we have here? Let's take a look at this together, right? So we have first person1 is just a of type person of struct, which is a person, and it has a person. It's a type person. Now here, last name is last name. So this is basically about showing implicit value assigned if you don't provide them, right? So as you can see here, basically last name here is an empty string, right? So if we you can see because we didn't provide the last name to the person, the last name is an empty string, right? Because it's always going to be whatever the default value. So in Go, a string, if you have a value that's of a type string, its default value is going to be an empty string. For the numbers, it's going to be 0. For pointers, it's going to be basically nil. And then there's a few other types which are a little bit different. Because you have initialized and non-initialized array or a slice and stuff like that. So we're not going to talk about that now. But there's slight variations. Then here for the person, if you just initialize a struct without providing any values like this, then the name and last name obviously are going to be empty string, right? So if we would print, so let's just print them. Let's print person3. So if you print person3 here, you're going to see actually that we're getting an empty object. If we print the person1, we're getting John. But you can see here actually that if we had age, just as they had in their example, int, and then we print this thing again, you'll see that we're getting an actual empty value. Actually, so keep in mind, don't get confused that we're getting an empty object here, is because I think it's just how I'm using the print statement. So you can see that I'm not getting an empty string for the last name, but last name is indeed empty string. I'm just not very good at using the FMT library yet, so I don't actually know which arguments that I need to pass it, but trust me when I tell you that last name indeed is an empty string. So this is just basically, this example is supposed to show you the initial or the default values of some of these things, right? And they don't differ in the context if they are structs or not, right? So that's a little bit why this example that they have in the documentation is weird, is because these rules apply no matter where you define these values. If you create a variable, if you come here and say var name string, right, this is going to be an empty string by default, right? So there's really no difference. And I don't actually know what was their point in this context here, but as you can see here, we have a pointer type that points to a person, basically, right? And as you can see, we have this ampersand in here, right? So if we print person4, we're gonna get bar, baz, and 0, and we're getting the 0 again because of initial value. We didn't provide the age. If we do provide the age, then it's gonna be the age is gonna be there, right? So I suppose that this example is supposed to provide a way to see the default values when working with structs, but again, I don't think there's an exception here at all. I think it's the same with assigning or not assigning values to any types. The type nonint is an array. Okay, so now we're at the arrays, right? So, but before we go here, so let's just recap once more, right? So we just worked with pointers, right? And we saw that a pointer really is just a variable that points to the address of another variable. So it's pointing to the place in memory where that value is, but it's not telling you what the value is. You have to dereference it to get the value. So when you create a pointer that points to some value, you are essentially, at least so far with the examples we had, you're saying, hey, create a variable that points to the address of some other variable. And then you can, and why do we do that? Well, so let's actually play a little bit with pointers still, because I don't think this was clear enough. That's why I say this documentation, this tour of Go is great in one way, but it's not so great. It's not too great. So let's imagine, so just as I showed you in JavaScript, with the references and passing objects to functions in JavaScript, let's do that a little bit of that in here, right? So if we have some structure, so if we have type person struct, and we have a name, which is going to be a string, and I keep adding the colon, which doesn't exist here. So actually, you can see that this guy is already trying to do something with it. So let's say here set name by reference, and we're gonna update these things, and let's say set name by value, right? Well, there's no such thing as instantly pointers, OB, I think. It depends how you pass them to a function. That's what I'm trying to show now, right? So let's do something here, right? So what we're gonna do two different functions, right? One is gonna be so here we're gonna say pname is oh shit, my bad, sorry, this is a receiver functions. Okay. All right. And we don't really have to return anything here, so we can just omit the return statement. There's nothing we want to enter. So we have two functions now. One is taking a person as a pointer, and this would be how JavaScript works, right? And then another one, we have another function that gets the person as the value, right? So let's see what we here now. So let's say here var person, we say person is person name, let's say Leo, and let's see how we use this now. So let's call, but the problem is I didn't want to create a function. I didn't want to really create a function receiver. I wanted to create so let's change this slightly a bit, right? Because I just wanted to create a normal function, right? So because we didn't get into receivers yet and stuff, so let's not do that, right? So we're just gonna create simple functions, and here we're gonna take p person, and what is it complaining about? Mix the names and a name part. What is it complaining about? Ah, I see. Shit. Jesus Christ, man. Thank you. All right, and then person. And then let's come over here and we do the same, right? We're going to do pretty much the same, but we're going to omit the pointer, right? So if we omit the pointer here, right? Pretty much the same thing. We're going to do the same thing. We will not really return anything, and we'll just do we actually just copy that thing like this. So we have two functions now. They're not function receivers, so they're not part of the struct. They're just two normal functions, and they take the person and the name, but they take person differently. One of them takes the person as a reference, as a pointer, basically, and another one takes it as a value, right? So now we create a person named Leo, and we want to change the Leo's name. So here we say, so let's see what happens now. So now we say set name by reference person Leo, and then we print the person. Let's print the person here. So we go and we run this simple Go program, and I guess do I have some typos somewhere? No, I don't think so. Let's try that again. And we're missing FMT, right? I don't know how the hell that ended there, but that's what it is. So we do this, and we get Leo 2, right? So you can see now that the original object here was changed because we passed the actual address of the person, right? But if we called this fella here, so if we now basically just call the same the other function here, and we do basically Leo 2, for example, person Leo 3, but I'm gonna actually, yeah, exactly. So let's print the person again. You can see that the person is still Leo 2, right? Why is it still Leo 2? Well, it's because we passed a person here as a value. So this is, again, think about JavaScript example that I gave you, right? This is almost now as if in JavaScript you can't do this, because in JavaScript every time when you pass an object or any complex structure in JavaScript to a function, you're basically doing this. That's why we have to, if you remember, we have to say, return, spread the person, whatever, blah, blah, blah. So that is how it works. Here in Go, you can choose, and this is the power of pointers in a way, right? The core reason why you also have them is that you can choose when do you want to make a copy and when do you want to mutate the original value, right? And as you can see here, calling this didn't do anything. So typically from functions like this, you would not really, there's no point doing this, so you would actually return a new person from here. So it would say person, right? But then here you would say person.name is that, and then return person, right? So now in this context, if you truly wanted to do this, right? Well, now we would say, hey, well, now take the person and then assign it to whatever person this, and this is immutable way, right? So this thing now takes the person. In JavaScript, you would say make the copy and then return a new person, right? So now if you run this program, right, we'll see that things should look properly. And I guess I'm not printing it, so let's print the person here again. And the person now should be Leo 3, right? And as you can see, it is Leo 3, right? So this is the more pragmatic and practical example of pointers, and this is how you're gonna use them in Go for the most part. You're gonna have functions, especially when we get into libraries and frameworks and stuff like that. This is gonna be the way that you use them, right? So this is typically, again, how you use pointers, right? You either pass something by value or you pass something by reference, right? So that is what's missing in this documentation, because documentation is very it's very theoretical. It's not very practical, right? All right, arrays. Let's get into that as well, right? So let's get into arrays. What are arrays? They are arrays, a data structure that can have a number of elements. Unlike JavaScript, in Go, if we take a look already, we don't have a, when you define an array, you'd have to define an array that has n number of elements up front. So you have to say this array has 2 elements of type string. So they're not dynamically allocated. You can't append really to this. You can see here, very good water here, yes. So you can see here, create me an array, a string array. So create me an array that can have 2 elements, and they can be strings. Create me an array of integers, and this array should be able to take 6 elements in total, and then initialize it like this, right? Now, there's certain different ways that you can more efficiently initialize things in Go. Unlike JavaScript, when you initialize an empty thing, it's still using some memory. It's still allocated somewhere in the memory. In Go, you can declare a variable and then initialize it later in time programmatically if the program actually needs that value. And that's what make function in Go does. Make, essentially, you have a function make that you can use to initialize. So initialize declared variables if your program flow needs it. So you can declare the variable, say, hey, I might need this array or whatever, this slice, this map. So just declare it, but then I'm going to initialize it later. So it's more memory efficient as well, because you essentially don't have to, because the point here is that oftentimes you don't have to declare and initialize variables that might never be used in your program. Imagine this. Let's just use a JavaScript example, right? So imagine that you have a program in JavaScript that has const array, and then you have 1, 2, 3, 4, 5, right? And then you have some function that does something. Now, and let's imagine this is actually in the function scope, right? So you have a function array here. But then what if in your program flow you say if something goes wrong, you say throw new error, I don't know, something. And then here, basically, you are using the array value, right? What is the downside of this program? Well, the downside of this program is that you have initialized something already that might never be used, because if this fails, you have this allocated this memory for nothing, right? Of course, you could solve this problem in JavaScript as well. This is more about how you write code, so you don't really have to do this here at all, right? You can do it later in time when you need it, whatever, right? But either way, in Go, you can say, well, create me declare a variable call of type array int, whatever, and then later in time, I'm going to initialize it with something, right? So we just prepare the variable itself, and then we initialize it in time, right? So anyway, when it comes to what is the reason you learn? Go is a beautiful language. It's truly one of the most beautiful languages out there, if not the most beautiful. And when I say most beautiful, it's not that it doesn't have some synthetical things which are not very beautiful, but overall it's a very stable and very nice language. And I think it's a good language to learn, even if you're not going to use it to enforce your existing knowledge. And let's say if you're a JavaScript developer, you can learn a lot from Go, how to handle errors. You can get some extra insights and extra enforced thought process on the things that you already know, right? And I think this is but also we want to use Go in Programmer Network as well, and I want to use it at work. Where I work currently, we use Go. So there's various reasons for me. There's a professional reason. It's also Go is undeniably growing a lot in popularity, and Go is an infrastructure language. It's a DevOps language. It's a cloud language as well. Everything in Kubernetes and everything currently in the cloud is very Go native. So it's a very good investment as well. So I actually haven't spoken about this when we started this series of streams, but Go is your time investment in Go is a very good investment of your time, right? So do you play games? Unfortunately, I do not. I have a wife and a kid, and a full-time job, so I don't have the time to play games. But I would probably play games if I had the time. But I have the stream, and I have a kid and wife, and my time is just booked to play games. I don't have the time for that. Because if I would play games, then I wouldn't be able to stream or record music and stuff like that. So yeah. Anyway, so arrays are no different than arrays in other languages. If you know arrays in any language, it's more or less the same in Go. The difference again is that Go is a strictly typed language, so when you define an array, it has to be of a certain type. JavaScript arrays are mixed, so in JavaScript and TypeScript, array can have one element can be an object, another one can be another array, it can be a function. So arrays in JavaScript are different. They're by nature dynamic, so when you create a JavaScript array, you can push, pull, remove from it. It's completely dynamic in every sense of that word. In Go, it isn't, as you can see. You're very constrained up front. You have to know up front, okay, I need this list of comma-separated values of some type, and you need to say how many you need, right? How many of these are you going to need? So, and this is, of course, so the compiler can be efficient with allocating memory. Otherwise, what would it allocate, right? So when you say, hey, I need this to be a string of this many elements, it can know better how to efficiently allocate things. Yeah, exactly, Max, exactly. All right, cool. So let's move on. Slices, as you can see, slices are probably more common thing that you're going to use in Go than arrays. Why? Well, slice is now we're getting a little bit more closer to JS, if I may, right? As you can see, an array has a fixed size, which is a limitation in most cases, because sometimes we don't know the size of a list of some sort. Sometimes hey, give me all posts. I don't know if it's going to be 5 posts or 500 posts. I don't have that knowledge, right? So yeah, an array has a fixed size. A slice, on the other hand, is a dynamically sized, which is useful, right? It's not to say that one neglects the other. I'm sure that there are many applications of an array, especially if you're building a video game or whatever, and you have some state that that makes sense to use an array for. So, right? So for sure, arrays have their applications, but slices seem to be more realistic in real life scenarios while building APIs when fetching unknown amount of things, right? So as you can see, is dynamically sized, flexible view into the elements of an array. In practice, slices are much more common than arrays, right? So they're indeed much more common, but it's not to say that one neglects the other, because again, there are applications in both. It's just that the slices are more common in real software, right? The type T is a slice with element of type T. So it's no different than arrays. A type has to be defined and it can't be mixed. So that's pretty much it. If we copy this thing into our VS Code, yeah, what can we say? It's pretty much almost exactly the same syntax as an array. If we actually go back and just copy the array example, right? So if we grab the array thing and we put it here, and actually, sorry, I didn't want to copy that. I wanted to copy something else. Your streams are the best. Thank you very much, man. I appreciate that. That's very kind of you. That's very kind of you. So what do we have here? So we have the S for a slice. Why are they called slices and not just dynamic arrays? That's a very good question, honestly. I don't remember. I'm sure that there's a theory behind it. I don't genuinely remember, but it's a very good question. So what do we have here? We have, so let's actually see what this prints, right? So what do we have here? So we have something called S that has this brackets. It has an int, right? And then it has primes and 1 and 4, right? So what does this mean? what is this, right? So if we go back to the documentation of slices, you're going to see here, just like in many other languages, it says a slice is formed by specifying two indices, a low and high bound separated by a colon. So basically this means that if we take a look logically at this example here, 1 and 4, we got 3, 5, and 7, right? So basically the low bound in our case is 1, the high bound is 4, meaning we define the start and end point of our slice, right? So our slice basically is 3, 5, and 7 because we skip the first one and then we go up to the fourth one, but it's not inclusive of the rest of them, right? But it's again a little bit strange example that they're using, because this would be more it's a little bit strange way to create a slice, because they could have just as well created a slice like this, initialized it, right? Like this, for example. What am I doing wrong? Jimi Hendrix is playing. Oh my god, that's beautiful. Okay, let's just go. Slices are like references to a slice. Does not store any data. It just describes a section of underlying array. Yes, changing the element of a slice mode. But those are such a silly example. Is there? Yeah, slice literals. This is what we want, right? It's just I don't know why my code doesn't work here. Let's try that again. It should be working now, I guess. Yeah. Okay, so forget about what you just saw there. So again, that's why we need to kind of break down some of these examples, because they're not very good, right? So as you can see here, because those previous two examples that we just taken a look at are just a combination of arrays and slices, and then they're basically showing you, hey, you can break, you can take an index of start and end of an array, and then create a slice. Why is that useful to know now is unclear. But basically they're saying, hey, I have some array that has some elements, and if you want to create a slice of that array, you can start at index x, and which is what they call lower bound, and a higher bound, which is the last index, or the index that you want to go up to, not inclusive to the next one, to further than that, right? But anyway, so a slice literal is like an array literal without the length. So this is the important stuff. So as you can see here, the difference between the slice is that we can, in fact, omit the actual length, which makes it a useful array, basically, right? So, but we have to refer to it as a slice. And as you can see here, this is our slice, and we initialize it like this, right? Now, you don't actually have to initialize it like this, right? You can, in fact, leave it empty, right? Like this. And then you can also initialize it later on, right? So as you can see, we can just create an empty one and then initialize the values later on, right? And we're gonna see that in a second, I'm sure. Hopefully we're gonna see that in a second. So let's actually copy their example here as we did so far. So as you can see here, we have our first slice called Q, then they print it. We have another slice with booleans, nothing special. We have a struct here, and we have basically, so this is, think of it in the JavaScript sense as you had an array of objects, right? So here we have a slice called S, and this slice has struct with I and bool, right? Again, those examples are not very good. They're very cryptic in a way. Again, I don't know why they use this shit. They should just use person or alien or whatever, just so it's a little bit more clear. But imagine this is name string, and then this is last name, whatever. So this is an array, dynamic slice of I and B. Not very readable, I know, right? Okay, let's go next. Slice defaults. Yeah, very important as well. So what does it happen when you define a slice and you don't give it any values, right? I guess. So let's see what's happening here. So as you can see here, that's not the example. So here we have a slice, and we're reassigning things, and we're using the so they're now trying to. So this example is about omitting the bounds, either the So this is think about this in JavaScript like using slice or splice, which is mutable in JavaScript, and then omitting some of the bounds, either the starting or the end index, right? So think about it this way, if I can get it closer to something that you already know. So imagine that I have an array in JavaScript that looks like this: 1, 2, 1, 2, 3, 4, 5, and then you say slice, and then you say 4. Then you get 5. But if I say 1 to 4, then I get 2, 3, 4. So you can see if we omit the last value, right? So slices, you can see, takes the start and end. This is more or less what they call lower and higher bound in there, and they'll work slightly different. But if I say start at the first element and add at the second element, right, we're gonna get 1 and 2, right? So start at first and end at third, right? But not inclusive, so that's why we're getting 1 and 2. So this is what they're talking about here. What actually happens when you omit some of them? So here we have 1 and 4. So we're skipping this one. You can see we're counting kind of with 1. So you can see one difference with JavaScript that I show you is that we're not using 0, we're using 1. So it's saying, hey, take this. So you can see it's not inclusive any of the bounds. So omit this and then the rest of them. So go from 1, so 3, 5, 7, and then stop there, right? So this is the 4. But then here we have the example when we omit the lower bound, and then we get 3 and 5. Which is, we get those two, right? So we're saying just omit the first one and then go basically 2. So this would start at the start of the slice and go up until the higher bound. And then logically, if you think about it here, it's very logical. Here we're getting well, this actually, is this really logical? Because here, yeah, this one isn't very logical, is it? Because here we're getting 5. Let's try to discuss it together. Why are we getting 5 here? Anyone? So here we're missing the upper bound, right? But we have 1. Why are we getting, when we print this, why are we getting 5? And actually somebody posted some link. Let's open it. Give me a second. I appreciate that. I'm by no means... yeah, okay. Nice. Amazing. We're going to take a look at this. Thank you very much for that. Appreciate you sharing this. It's different than JS. But what do you mean it includes that number? Let's decipher it together. So why is this thing returning 5? Because this is our starting, this is where we want to start. So we're saying start at 2, right? So why does it only include 5 if we don't provide the higher bound? Let's see. When slicing, you may omit the high or low bounds to use their defaults instead. The default is 0 for the low bound and the length of the slice for the high bound. Okay, right? You get it? It's because there's 5 elements. So 1, 2, 3, I guess. So 1, 2, 3, 4, 5, 6. So here, basically, in this context, if we omit the, you can see here where it says, this was for the low bound and the length of the slice for the high bound. And the length of this is 5, right? So if we do, you know, if we do fmt.print ln and we say len and we say s, right? Actually, it returns 6, right? So that's a little bit weird. So I guess this becomes this, right? And that's why it's 5, right? No, that makes no sense. Let's see. What the hell happened here? What did we get? Yeah, because there isn't 6 elements, right? We're getting oh, we are reassigning it. Sorry, Jesus Christ, it's out of bounds. No, but you're absolutely right. Of course, yeah. You guys are 100% right. That's why I was losing my mind. Yes, it's being reassigned indeed. So at this point, yeah, of course, yes. You guys are absolutely right. Yes, because in this context we are omitting 3. Thank you. Yep. Okay, that's good. Yeah, laugh at me. Just laugh at me, yeah. Okay, so but let's stick to this a bit. So the default is 0 for the low bound and the length of the slice for the high bound. Yeah, I was also freaking out a bit. Okay, but I think it's quite clear. It's a little bit weird, especially coming from languages that start counting arrays from 0, right? Okay, great, awesome. Yeah, same to me. I'm not an expert at Go by no means. I am genuinely learning with you guys as well, a lot of things. Slice length and capacity. A slice has both a length and capacity. The length of a slice is the number of elements it contains. Logic, right, like in most other languages. The capacity of a slice is the number of elements in the underlying array counting from the first element of the slice. The length and capacity of a slice S can be obtained using the expression len S and cap S. Yeah, so this also makes sense. Let's take a look at this together. All right, so let's run this, and let's see what it says. All right, so let's take a look. So we have some array here, right? Or a slice to say, and the capacity is 6 because there's 6 elements in here, and the length is 6. You get what's happening here, right? So you have a capacity and you have the length. So you have how long is the current array, how many elements it has, and then how many elements is the actual slice, right? So as you can see here, so here this is 6. This S has capacity of 6 and the length of 6. Then in here, it has a length of 0, but still capacity of 6 is because we haven't selected anything, right? We haven't created any slice. We haven't used the bounds in any meaningful way. This is a little bit shitty. It's not super... I don't like this implementation. Then we have, I guess, where are we? So 1, 2, 3. So we have this one, which is where we're here. The length is 4. Capacity is 6. But again, look, this is not, again, we have to be careful. This is not to memorize this. This is not to say we have to memorize every single data. We're going to be using slices when we start building some of the APIs and stuff. So don't worry too much about all of these details. It's not relevant. It's just to get some muscle memory going and just memorize some of these things, right? Fundamentally, the only thing really we have to memorize at this point, the only thing we have to memorize, none of this we have to memorize. This is irrelevant. This is the stuff you don't memorize. Once you memorize this, well, capacity can be useful, OB, for you to know how to determine your bounds, right? So that's how. If you know that something is, let's say, has a capacity of 6, then you're not going to try to create bounds that go up to 8, for example, right? So that's why. But again, this is not something you ever explicitly memorize, no matter the language. This is the type of stuff that if you memorize, if you ever memorize, that means you're building stuff with this. So this is by no means we have to memorize every single low-level detail, right? Of this, we don't. It's irrelevant, right? So we don't have to. This is just to play a little bit with it. But the only information we have to kind of remember here is that there's an array which has to be defined, which has to have defined length up front, and then there's a slice, which is something that's more common that we're gonna use. Now, all of the underlying details and methods that this exist, how do you push, how do you pull, this is the stuff you don't want to memorize when you're learning a new language, because you know what a pushing to a slice is, or array, removing stuff from it. You know that there's some length of it, right? So this is the stuff you already know, so you don't have to memorize. When we start building our services, we're gonna go back, and if we need some of these methods, we're gonna read the documentation. So we're not going to lose our mind over this. This would be a super inefficient way of learning new stuff, because now it would be a completely bottom-up approach, and you can end up in this hell for 2 months, right? It's like, who cares? We cannot build things like that, right? The zero value of slice is nil. So if you initialize a slice if you declare a slice without initialize a value, it's nil, and that's what they're saying. So essentially, if we copy this is not a bad stuff to kind of at least know a little bit, because it's just some types and stuff. So one would be reluctant. So why is this kind of good to read, at least for us now? Because coming from some other languages, one would be reluctant to use .length in this now, right? And maybe we even can, right? What would happen if we would say, what would say len s? Can we do that? And I assume that this len understands what we mean. So as you can see, it does, in fact, right? So, and give me 1 second, sorry. Ah, shit, that's passed the argument to the wrong thing. So it actually does understand, so it's good. But it's good to know that it's nil, right? And we'll see a lot of these nils across Go journey a lot. A lot of things in Go are nil, and we'll see about that a lot. So yeah, so a nil slice has length and capacity of 0 and has no underlying array. Fair enough. So that's an interesting detail. Creating a slice with make, yeah, okay, so this is a little bit important. It's not important to remember the make and syntax of it. That's less relevant. It's more relevant to understand what make does. It's because it's a little bit weird. So let's read about this together. Slices can be created with built-in make function. This is how we create dynamically sized arrays. The make function allocates a zeroed array and returns a slice that refers to that array. I'm just reading this and thinking, like, how can this make actually sense? Because this is so school-like. Slices can be created with built-in make function. This is how you create dynamically sized arrays. The make function allocates a zeroed array and returns a slice that refers. I don't think we should discuss this now. This is meaningless. It has no purpose in this currently. I don't see right now where that's Iron Maiden for life. So let's not. This is too much. This is going. First of all, you don't just introduce a function like make just out of the blue like this. So I'm gonna skip this. Useless. Multi-dimensional slices. I'm gonna skip this because again, it's multi-dimensional arrays. So in JavaScript, in many other languages as well, you can have an array of other arrays, right? So if we do const multi-dimensional array, right? Typical for video games, grid type of systems and stuff like that, right? That, you know, yeah. So that's what it is. Again, this type of stuff we're gonna get to when we start building things. This is interesting. So let's get familiar a little bit with their API, with a standard library. So how do I append things to an array? Because, for example, in Go, you cannot append to an actual array. You can only append to a slice. So how do we do it? This is a print statement. Yeah. So how do we do it? Very simple. In JavaScript, you would use push for arrays, for example, but you could also use various other methods. Here we create a slice. We pass a slice reference, and we pass the value that we want to append to that slice. So that's really all that there is to it. So we use append method. The compiler knows how to handle this. So in JavaScript, if you remember, we have prototypal inheritance. All of these methods are on the actual prototype. So array.prototype, object.prototype, etc. Go is a compiled language, not interpreted language like JavaScript. So here, when compiler finds the append method, and based on the arguments, it knows how to deal with that thing, right? So yeah, so to push to an actual slice, we use append. Nothing major. In most languages, it's like that. Let's see. It is common to append new elements to a slice, and so Go provides built-in append. The documentation of the built-in package describes append. We'll actually, when we start building some services, we're gonna be using their documentation a lot. It's truly an amazing documentation, really good. One of the best documentations I've read, and in fact, it's the best place to learn Go, really. And their whole standard library, just like STL and C++. C++ has a huge template library as well. I have a book on this. I don't actually remember when I was writing this which documentation I used. I don't think that exists anymore. But yeah, anyway. So actually, let's maybe spend a minute on that. So yeah, so let's go to append here. So where is the append? So func append. So let's just, we haven't actually touched base on this yet, right? So you can see we have a function append. It can be a slice of some type t, and then some elements we want to append, and then it returns the actual type. And then here you can see how you can do it. You can append another slice, meaning create a multi-dimensional array, multi-dimensional slice. You can append multiple elements, comma separated. No, it's so compiler knows how to handle it. This is a little bit more complicated now, getting into bytes and stuff. And then we have the return type. And then basically, so the beauty of this, what I'm trying to showcase here is that you really have the standard library documentation, right? So now we can, of course, go with a tour of Go, or you can say, well, okay, while I'm here right now, how do we clear the actual, how do we clear the slice? How do we delete from slice, right? How do we get the length of a slice, right? How do we copy the actual slice, right? So this is the beauty of it, right? So as you can see, it's quite nicely composed here, and it's awesome, right? So that's great. The resulting value of append is a slice containing all the elements of the original slice plus the provided value. So this is great, right? So you can see that. Now the question though is this mutable or immutable, right? So are we actually mutating the original slice? We are, right? So just because this is returning the slice that's updated, it doesn't mean that it is mutable in fact, right? If the backing array of S is too small to fit all the given values, a bigger array will be allocated. The returned slice will point to a newly allocated array. So yeah, so if your initial array is too small, it's gonna create a new array with that size. Range. So this is another way to loop through things in Go. In the first stream, we spoke about for loop. There's a range, and it's pretty simple to use. and it's very common to actually see. So as you can see, just like with standard for loop, we initialize some variable, then we assign range to this v, and then we pass in the in this case a slice that we want to loop through. So very common to what we've seen before in other languages as well. And then as you can see, for each value in this slice, in this array, we print the value, right? And range basically is a keyword, it's a function pretty much, right? So this range over this this slice, right? So this is, again, in order to memorize a lot of the syntax, we'll need to write some Go, right? Obviously. But that's really it. So if we take a look at the standard for loop, right? It's not that different, right? So it's a for, exactly. So if we really compare the two, right, there isn't too much of a difference. And we're gonna see, using range also for maps and stuff like that, where it's slightly different. It has an extra variable that we declare, but fundamentally it's what it is, right? So have a simple for loop, and then you have a range for the arrays. And range is used quite a lot in Go. It's used quite a lot. It's like map in JavaScript, right? Or reduce or whatever. And yeah, so let's take a look at this. So this is very interesting, right? So, and this is an interesting one. So this is an interesting one, right? So so as you can see, range takes an index and a value, right? And you can compare this if you know in JavaScript, right? If you use a map, for example, .map in JavaScript, right? Or for each. So if we use, let's use for each would be a better. So in JavaScript you have for each, and then for each has a value and an index, right? You can see JavaScript developers have actually done a very solid job in there, because they realize that they have reversed the argument list of this callback function in JavaScript, so for the value to be the first argument and the index to be second. Because I'm sure that when they wrote the spec and when they implemented some of those functional methods in JavaScript, they realized that for the most part, people will care about the value that you're looping over, not the index. In Golang, that's reversed, which I find a little bit silly. So in Golang, you have the index and the value second. And then what you're going to see in a lot of Go code bases, you're going to see this underscore. And this is the way to say, hey, I'm not actually using this value, right? And this is a little bit silly, right? Because you can see how such a silly technical decision can impact language to such a huge degree, because you will see a lot of things in Go where there's just underscores all over the place. Because again, hey, I'm looping through this list of integers, and I'm just interested in the value. I don't give a shit about the index, right? But you have to then, you still have to type it out and say, well, an underscore. This means like, hey, it's not used, right? Whereas in JavaScript, if you remember, the first argument to a callback function is the value, and the second is the index. So for the most part, you never really, in reactjs, for example, you would use this index sometimes if the list isn't too big as a key. So a reconciliation algorithm knows what to update when things are, when it needs to update the actual DOM, right? So yeah, so that's the range. As you can see in the range, you can get a key and you can get an index basically, and you can get a value of the element we are looping over right now. Exercises. I think all of us should do this in our own time. I'm not gonna do this now because the stream is gonna go too long. So I will actually do all of this stuff on my own, and I think you should as well. Let me just share this link there, just to get some muscle memory. And shit, I missed a lot of messages on YouTube. Sorry guys, on YouTube, I haven't been paying attention to YouTube chat. Good evening, everybody. If you're still there. Maps. Okay, maps. Maps are very important, right? Hash tables, maps, objects, they come in various names. But they represent, in many cases, a very similar thing. They're not always the same. There's some difference between them. But in JavaScript, we really only have an object. We don't have a hash table. But it is really all the same thing, right? So here we have a map, and map is the most efficient and or to say probably the most used data structure out there, right? It's used because of quick access. It's used because, yeah, we are very clever. Developers are very clever in mapping things in a clever way, so we can, even the caching databases like Redis heavily depends on hash maps, and even the whole caching ecosystem depends on being able to, even programmer network platform, if you notification system is fully built around basically hash tables, right? Cool. Anyway, so of course their documentation is using shitty names, vertex and stuff like that, so fuck that. But actually we can leave it for now. So we have latitude and longitude, it's float 64, let's see what we have. And then we have a map, right? We create a map. Let's call it, with cautious, let's call it object, just as a reference to the JavaScript. But here, what we do, we say const, this is JavaScript equivalent, we say m, and we do this, right? Now, if this was TypeScript, then you would do some record or whatever. You would say this is a, in TypeScript, you would say this is a record of key value, whatever. It doesn't really matter. I just want to kind of get you closer to what it is. So we create a map which has a key of string and a value of vertex. And the vertex is basically a struct, an object as well, in a way, that has a latitude and longitude. It has two floating point, two decimal numbers. And yeah, so we use the make here. So the make itself is a little bit, there are two things to explain here. What is a make and what is a map, right? So in Golang, right, there's this make function, and this make function initializes a map, right? So when you define a map like this in Go, you can't assign values to it because it's not initialized. Now, of course, we could have initialized it here by, giving it some values like this, or we could have called the make inline like this. And now here we would be able to assign values to it. But if you remember a couple of minutes ago, I spoke about that in Go, you can, when it comes to maps, for example, you can declare something and then initialize it later in time. So you have a choice to not allocate memory up front in case that maybe that map doesn't even get used because, let's say, your program exits, panics, or whatever. So you're not wasting memory, right? So you can see here we said, let's imagine that this was JavaScript and you said const m is empty object, right? But imagine that this empty object was like frozen or whatever. I mean, it makes no sense, the example, because object freeze does something else. But fundamentally, imagine that in JavaScript you created an object, but you can't really use it. You can't change anything with it. You have to somehow then somewhere further down say, hey, how do I actually can add things to this object? So that's what's happening here. So we declare a map which maps a string to a vertex, which a vertex is here just a shitty type. If this was, it would have been better if this was just person, as I use this whole time, and then we have a name string. Let's just do that instead, and then just so it's and then here we'll say name Alice, whatever, right? I think it's easier to understand. So we have a simple map. This doesn't have to be a struct, of course. I mean, they went a little bit crazy. This can be a mapping between two strings, or an integer and a string, right? So key has to be a string, and value has to be an integer, right? So this is just they're mixing up a bit, right? And as you can see again, so make is a little bit a strange thing. It's in many languages. Not in too many languages it's common that you declare something that you can't use until you initialize it like this. So that's what make does. It basically, in this specific context, it says, hey, actually initialize this, and now then, because I want to then assign some value, I want to extend this or create some mapping. And then here we create a mapping. We say Bell Labs, and this maps to this object, right? So this is, again, why am I emphasizing the make? Why am I emphasizing the make here? Is because it's not super common. So in fact, I'm sure that map is clear for most people, but make is like, okay, because like if you didn't have this line, right, then this would not work, right? You wouldn't be able to do this, right? Right? You see, it exits basically with some stuff, right? Now it's Alice, right? So and of course we need to configure our VS Code and stuff so we get a little bit more better. Like we need to run some of this stuff in some more verbose way so we get some meaningful errors from Go compiler, because right now, right, if I don't initialize this, and we'll learn this together in time, I have no doubts, but right, actually no, panic assignment to entry in nil map. I mean, is this useful? Who knows, right? I mean, in this program, which is 10 lines, probably it is, but if this was a real stuff, so we will use the debugger just as we use in Programmer Network project. We're going to be using the debugger, the Go debugger here, and that's another reason why Go is also amazing, is because there's no transpiling, there's no conversion from 15 different things, there's no Babel's JS's, there's no Webpacks, Vitas, and whatever, right? It's just a simple language, and we can use a debugger. And in fact, if you're writing a language like Go, and I mean, when I started writing C and C++ when I was younger, you know, in Dev C++, in code blocks, the debugger was for me the way that I ran my code. Like I didn't have like some command to run some arbitrary binary. So it's like if I run my software, I run the debugger, right? Because there was no print statements to this degree. Now, whatever you debug some shit, you just print stuff. It's not very efficient. Okay, so what are maps again? To map hash table and object, just a way to map things, and you can access them with. We actually haven't said that. In Go, you access the values of a map by using those brackets, right? So in JavaScript, you can do both this and dot notation. In Go, you can only do this. Map literals, let's see. Map literals are like struct literals, but the keys are required. So what are they saying? They're saying that you can't omit both things, right? If you want to initialize an empty, if you want to initialize the map with something, you need to provide at least the keys. So as you can see, map literals are like struct literals, but the keys are required. So in simple words, you can't initialize a map by omitting both, even though in this context, because there would be nothing in there, right? But you could technically do something like this, right? So that's what they're saying. You can omit the value, but you cannot omit the key. So right, so this is fine, and then you can fill this stuff up later, but you can't omit both, right? That's the rule. That's pretty much what it is. If the top level type is just a type name, you can omit it from the elements of the literal. I don't actually understand this. Let's take a look at it. I don't understand what they. And thank you everybody for your follows. There's been a lot of follows. I haven't been able to say thank you. Okay, so what are they saying here? If the top level type is just a type name, you can omit it from the elements of the literal. I see what you're saying. Yeah, I get it. Okay, so you don't need to put it. Okay, you don't need to put a type in the value. Got it. Okay. I see. Okay. Makes sense. Yeah, we're gonna make everything. The whole fundamentally this stream is always gonna be about Programmer Network, right? Right. But I have to mix up the streams a little bit, right? Because first I want to have some fun with people. I want to build some things together as well. I want to build more open source. Past 2 months I've open sourced 2 or 3 things, right? If you take a look at my GitHub, we built some pretty cool things, but I think it's again, it has to be fun for me as well. I cannot just, I'm building Programmer Network off stream and doing some stuff, but a lot of the things are not very fun. They're not the stream content. They're a little bit boring. Fixing some things, right, isn't Yeah, exactly. So you're saying we can omit basically this, right? Is this what you're saying? No. We're not gonna. We for sure we're gonna. We're gonna write Go. I mean, no question about that. All right. So let's go next. Mutating maps. Okay. This is very simple. We're gonna spend 25 seconds in this. It's pretty much the same. So how do we assign values to reassign values, assign new values to a map? It's the same like in JavaScript. Again, I'm always going to use some reference to something that people already know. In JS, you would say object dot answer is 42. It's the same in Go, no difference. M of something is 42. M of answer 48. Every language is good to find work if you're skilled in it, and if you so I think Java is a very old language, and it's I'm sure that there's millions of jobs in for Java and for PHP and for JavaScript, right? There's 3 billion devices using browsers and 4 billion people opening browser every day. So I'm very sure that there's jobs for every programming language out there, and yeah. Okay, and then basically, so let's just take a look at this very quickly, right? So basically, as we saw when we look at the documentation of slices, for example, this is the same for the maps, right? So for example, if we jump here to map, actually, can we? So let's take a look. So standard library. So let's go back to documentation. So if we go back to where is it? What did I want it to do? No, that's not what I wanted. Like if we go to standard library and search for maps, yeah. If we search for maps here, what is Golang? Golang is really a language of infrastructure, DevOps, and cloud. There's no language more native to the GCP, AWS, and Kubernetes, for especially to GCP than Go. So for example, if you stumble upon a company that's using GCP, there's 99% chance that they're writing Go. Dream Data, the company where I work, everything is written in Go. Only thing that's not written in Go is our front-facing API that's serving reactjs. That's written in Fastify, nodejs. Everything else is written in Go. It's because Go is just a beautiful language for infrastructure. It's very native to Docker. It's very native to the cloud. Well, depends what it is. I mean, the only true isomorphic experience you can get is with JavaScript. So if you want one language to rule them all, this is not this is a factual thing. The only language where you can write both ends currently is JavaScript, right? So you can write Node.js, you can write React, for example, Angular, Vue, plain JavaScript, whatever you want. This Next.js and all of this crap is basically a full isomorphic experience with one language, right? Complete business logic in JavaScript, no thanks. I mean, I respect your opinion, right? I don't necessarily agree with it. I mean, I don't think that the language determines anything about business logic. That makes no sense at all. I mean, you have to be obviously more specific. That's a very vague statement, right? But yeah, I mean, the only true isomorphic experience is JavaScript, is because the only language currently that works in the browser, right? So even if you're writing .NET or Go or whatever, your front end is going to be in JavaScript. You might render it in the server side, but it's still JavaScript, right? So, Dave, I mean, that's a very vague statement, right? You need to be, I mean, that's not how I discuss technical things, and this is not what I accept as any sort of meaningful conversation, right? Saying that it's much harder to understand and keep it safe makes no sense. That's a super vague statement. That's like saying nothing, really. You need to be way more specific. I don't know what you mean. Keep what safe and keep and hard to understand what. Language doesn't define how easy your business logic is. Your coding skills, your patterns, and everything else defines your domain knowledge of certain things. Labeling complexity of business logic to a language makes zero sense. You can write shitty business logic in any language, and that... Yeah, but I mean, but you're throwing super vague statements. I don't disagree that some things are better than others, but that's a super vague statement. You're saying, hey, Alex, some things out there are better than other things. Sure, but that's super vague. That's not sufficient for, right? For any reasonable conversation, right? I don't discuss things like that. That's very shallow for me, right? So it's not that I disagree with you, but it's like you said nothing of substance that we can discuss. You said, oh, business logic in JavaScript might be less easier to understand. I mean, that makes no sense. I'm sorry. Because how does the language syntax define the complexity of your business logic? Your business logic is related to your domain knowledge of the product you're building and of the ways and patterns that you're writing your... You can write clean architecture in JavaScript as well. You can write MVC, MV, whatever in any language. You can write... you can do whatever you want in JavaScript, right? So that doesn't make much sense. The only truth to your argument could be that JavaScript is a very open language, and it's easier to write it wrong. Yeah. Is that true? I think that's generally true, yes. Go is a beautiful language because it constrains you to certain things. That's why Go has idiomatic Go, and it has, right? But you cannot say that the business logic is harder to read somewhere because of the language, because business logic is not defined by the language. It's defined by the scope of your product that your product manager and your team makes, your domain knowledge, your understanding of the product, your understanding of the patterns, your understanding of breaking things down, understanding of complexity, and many other things, right? I will actually talk about the clean architecture in Go and in Node. I'm actually recording a video on that soon. I already have slides ready and stuff. We do actually write clean architecture at Dream Data. And clear architecture is a very dangerous path you can take. Clean architecture is very dangerous because it's often something that you might not need. That's the problem. The biggest problem with clean architecture is that, and once I record this video, you're going to understand what I mean. I think it's going to be a very interesting video on YouTube. But clean architecture adds so much abstraction that in some scenarios, sure, it might be useful, but in most scenarios, it's useless, right? That's the problem. Clean architecture and all the abstractions, because in clean architecture, you have... So basically, the problem with clean architecture, right? So the problem with any architecture, and also the problem of, let's say, object-oriented programming is very simple. Clean architecture is invented so let's just discuss this for 5 minutes, actually. This is a very interesting subject. Listen up. Clean architecture has been invented for the sole reason of you writing software in a way where you might one day replace your data store or your database with a different database. Or you might replace your framework with a different framework. So this is the core premise of it. Of course, you can say it's easier to test to some degree, sure. Separation of concerns, sure, etc., etc. So this is very theoretical. Fundamentally, on a pragmatic level, on the pragmatic level of building products, the chances that one day you're going to write a nodejs API and that somewhat you're going to switch to a completely different framework are minimal. For 15, 16 years of my experience in this industry, yet I haven't seen that happen. So I haven't yet seen an API being built for 5 years, and then somebody said, yes, let's now switch it up with something else. So the premise under which clean architecture is sold is, for most companies, most startups, a fallacy. The chances, again, that you're going to completely rewrite your... But what is the problem here? The problem here is that you invest so much time, so much effort, so many abstractions, so much overhead for an assumption that one day you might switch your Postgres with Cassandra DB or Neo4j or MongoDB. And this is the problem of developers which are very theoretical, which are very pattern-oriented for the sake of patterns, not for the sake of pragmatism. It's just for the sake of being able to say, well, we have this repository pattern, and then we have use cases, and we have this onion layer of things, right? And then we have, I mean, you cannot sell such a system for the sole sake of patterns. You have to find the actual value in it, right? Yeah, exactly. But this is a fallacy, right? I mean, literally, I've been in this industry since 2008. I've been working full time. I started as a Cisco engineer, and then I've been writing software for startups. All I haven't seen that yet. So look, I'm not neglecting that the architecture is an interesting concept. It is clean architecture is an interesting concept, but it never materializes. You invest, you add this huge overhead of layer on top of layer. So maybe one day, and look, for those people who actually end up doing that, they probably sit together and say, motherfuckers, you see, we spent countless hours on this, and you see now it materialized. The biggest problem is, how often does this materialize? Because look, if you take one endpoint that's written in a clean architecture way, so basically you have a use case, a repository, an entity, and all of this. You write an entity, you create your utility methods there for that entity and all the business logic, right? And then you take that same thing and write it in, let's say, Fastify, Express.js, or Go. You're going to have 7 lines of code in one example, and you're going to have like 5 different files with shit tons of abstractions in a different file, right? It's a huge difference. Like, I mean, the abstraction is huge. It's not like a tiny abstraction. Some people are now trying to take clean architecture and kind of narrow it down. Well, actually, we don't maybe need a repository pattern or some sort of a service, right? Oh, well, maybe we don't even... Yeah, but then you're fundamentally moving back to MVC, right? Because when Uncle Bob invented... When he came up with the clean architecture, his premise was that MVC eventually becomes unmaintainable for large projects, whatever that is. But I mean, a lot of people are moving from clean architecture back to the MVC because they realize that what is really, like, if we're real with ourselves, what is the actual chance that you're gonna go back one day and just switch it all up with something else, right? So but you're assuming that writing code using this code design is by definition harder than you would. It's not necessarily true. You could create a project structure and look. That's not the point. I don't think you understand me, Dev. No, that's not what I'm saying at all. It's absolutely not what I'm saying. Let me show you what I'm saying. Let me show you one thing. Let me show you what I'm saying. This is not about harder. There's no such thing, for me at least, in programming, like harder or easier. Let me show you what I mean. Let me show you Programmer Network API. Let me show you my API. So let me show you my API. So if you go to Programmer Network, the API that I built, let me just show you the difference in abstraction, right? So this is my API, right? This is a Fastify API that Programmer Network runs on. And in this API, I'm using ORM, I'm using SQLized.js, and I have my models defined here, and I have my router. So this would be like the most outer layer, the framework layer, right? Then I have my controller. Now in my controller, right, in certain places I have some services, in certain places I don't. That depends on the complexity, right? But let me show you one thing. Let's imagine that I had this change password thing, right? Let's imagine I just take this single controller, which is change password, right? If I rewrote this in clean architecture now, right, I would end up with around 4 or 5 times more code. And now this is, again, so we have to be very careful here. This is not to neglect one or the other. This is to truly seek for value. This is not about things being hard technically. Clean architecture is a very simple concept. There's nothing fundamentally hard about it. This is not to get into that. This is about to say, what is the long-term value? Does this improve developer experience, or does it not? Does this increase value of the product and develop? So this is something so this is not to be like absolute about one or the other. This is, it's about simplicity. This is a simple controller. This is how your, this is basically how, if you're not using clean architecture in Go code bases, how a Go code base almost identically looks like. You have some ORM or some service, you get some data, you have some utility functions or not, especially in CRUD operations. For the most case, if you design your database properly, if you have proper validation and serialization, whatever, it's really all that you need. The point here is truly to seek for, is something useful or not? Because if you take the premise under which clean architecture is built, again, as I said, not to repeat myself, it doesn't materialize. And like, for example, if you take a look at this, right, you're saying, well, if you have abstracted away these things into additional abstractions, so if you replace this by, let's say, MongoDB, you can do this. For me, the problem with that assumption is that there's no chance ever that in this project I would replace Postgres, let's say, with MongoDB, right? I think that onboarding people to this project would be 500 times easier than onboarding them to follow 5 different abstractions or 7. No, I'm not saying that nothing is abstracted here. Of course it's abstracted. So look, I'm not saying that all the abstraction is wrong. Of course that you need to have some abstraction. But how much abstraction? Like clean architecture does a lot more abstraction than this, right? I mean, in clean architecture, right, you have your, if we go from the outer ring, you have your framework, drivers, right? Then you have your controller, you have your router, controller. Actually, no, you have your router, which is in outer ring, so let's say router. Then you have your controller, then you have a use case, then you have a repository, then you have a entity, right? For example, this is always, of course, this architecture can vary. People implement clean architecture, right? Not a service. No, it's not a service. It's a repository. It's a repository pattern, not a service. Service would be combining repository and use case. So this you could say almost, but service is a little bit more broad. Repository is an abstraction. Think repository is almost like an abstraction over a collection. And in this case, imagine that we're talking about, let's say this is a user. We're talking about the user, let's say. Well, your repository would abstract all the methods that the user can do, let's say with some third-party service or a database. Entity would contain the business logic. Use case would be basically the boundary between the controller and but either way, look, this is now, we're getting too much into details. The whole point is this making things better and easier, or is it not? How much overhead is this adding to performance, right? Because you are, in fact, adding shit tons of more functions on your stack, right? Versus abstracting maybe just your data model. Maybe that's fine, right? Maybe you abstract your data model, you have some utilities, whatever. So it's not to say that one is better than the other. It's genuinely to ask the question, is adding all these abstractions worth your time, right? Because I don't think it is. And when I see amazing, like my code bases, like in Node.js, when I see some of the Go code bases, you can keep things so simple, or you can keep them very complicated. But the premise under which you make them, why you keep them complicated, is that maybe one day, right? No, look, again, absolutely, Dev. I don't disagree with you, man. I'm not saying that my solution to the problem is the solution. Absolutely not. There's always trade-offs, right? And my emphasis is always exactly on that word, trade-offs, right? You get what I mean? So you're absolutely right that there's so many ways you can do this. There's so many ways. For example, for me, yeah, well, actually, so even a dream data, right? Even a dream data, we had to rethink that, right? Because what I saw with clean architecture myself is that due to its verbosity and too many abstractions, there's so many derivatives or variations, permutations now of clean architecture, which just shows you kind of indirectly or even directly that people are trying to get around some of these abstractions, is because maybe they're not finding them valuable, right? But it's just to say, I'm just gonna make my point personally. I'm not saying that I'm right by no means. My whole point is you cannot take an architecture type of any kind and say this is the way we should write code. There's no such thing. There's so much context. Stage of your company, your software. There's so many things. And you have to be careful when are you going to make 6 abstractions for maybe good reason that you think at the time. But again, in my entire career, I haven't yet witnessed that somebody has, let's say, written the whole, whole Go API in certain way with a router. And then 5 years later is like, hey, let's just replace our, I don't know, Go framework with something. I'm not saying that didn't happen. Maybe it happens all the time. It's just I haven't seen it, which is why maybe I'm a little bit more skeptical towards embracing that blindly, right? Yeah, exactly. But look, Dev, right? This is also in a way something that to a huge degree you're right. But I think it's not that, like, there's nothing fundamentally here that I showed you that I can't test myself, right? There isn't really anything here that I can't test, right? Like, I mean, what I would test in here indeed is a little bit different, than I would test it, of course, differently than I would if this was abstracted in so many ways. But I mean, test what, right? I mean, for example, in your case, you're probably mocking up a lot of different things, right? So I mean, what are we testing? Are we talking about unit testing, end-to-end tests, right? Because there's so many things that change when we say testing in that context as well. What are you actually testing, right? Because with Fastify, for example, in this context, it's super easy to test all of this. So it also depends on the tool you're using, right? And then also testing, I mean, for me, testing business logic is the most important thing. Testing generic CRUD operations is probably the most useless thing out there, right? Because if you are writing just a simple CRUD, yeah, you're 100% right. Literally, I have to inject the Fastify application and run it 100%, yes. But it's super good discussion. I mean, actually, let me just see if the music has stopped. Give me a second. I had music somewhere. I think it stopped, right? Did it stop? Yeah, I think it did. So let's play some Brave New World album. But I appreciate the discussion, man. Very good points. Please, by no means, I state that my points are better than anyone's. It's just sharing my experience as always. That's what I felt in my career. Is that correct or not? Who the hell knows? It's way easier to be wrong in the in our industry, or to be right. I have double music. Shit. Oh, fuck. Thank you. Double music, man. Okay. All right. So yeah. So let's finalize this tour. Those 27 things, and then maybe we can chat more. I think that the core thing play one game is that no matter how you call it, there's MV something has 500 different permutations, right? The core point is that you want to decouple obviously your view from your database, right? So you have some sort of middleware pattern or something where you do that, right? So it doesn't really matter. Like there's so many different ways that these things are called, right? But I think you are rather looking at it from a maybe a little bit too technical perspective, right? Rather than okay, so we finished this one. Let's just finalize this super nice discussions. I actually have that book. The first tab is muted now. Jesus Christ, man. Okay. I actually have that book. I showed that book on the stream a couple of days ago. Actually, I bought that book when it came out. I think this was 5 or 6 years ago when I was at Iterating. I actually think I bought it on Amazon.co.uk. I don't actually know where I wrote it, but I think I bought it here many years ago. Let me actually try writing on. Did I buy it here or was it co.uk? I don't actually remember, to be very frank with you. Let me just fuck it. But I have the book. We might actually, if people stick for some Go in the future, we might actually. I tried. I think I got to around 30% of the book when I bought it, because you're literally writing your own interpreter in Go. But then this was long ago. Then I stopped. Do I learn C# or Java or any other? It doesn't matter, man. Like, learn any of the languages. You just need to. Both languages are great. All languages are great, pretty much. All of these languages are very old and very well established in the programming community. Okay, so let's just finalize this, right? So. Okay, so let's just do this. So as we saw, right? So let's just and then maybe we can chat. I just want to round up with this, right? So doing certain operations on maps in Go. So this is how we assign values or reassign them. This is how we delete the values. And then maybe one little detail, which is a little bit strange and I think very specific to Go, is that. I think I haven't seen this in any other language before, to be honest, so I'm gonna assume it's unique to Go, but if somebody else knows, please share it. So when you're accessing a property in Go that might not exist, you can rely on this OK property, right? So essentially you have the value and then you have this optional property OK. Of course you can call this banana as well. You don't have to call it OK, but in idiomatic Go, community calls it OK mostly. So this is basically, you can use this thing to see if the value that you're accessing actually is accessible, right? So I think I'm pretty sure that if element or OK have not yet been declared, you could use a short-term declaration from OK, right? So this is basically maybe something, I mean, worth noting for the future once we start building things. But you can see here, when trying to access some key from a map that might not exist, you can use this OK to know if it actually exists. So that is right. So you might say, hey, I want to access fruits.banana, and then say if OK, right? If actually that exists, do something, otherwise don't, right? So that is that. Exercise maps. I'm gonna do those myself off stream. I highly advise you guys before next stream to do it, so we can all be on the same page and share the same progress. I'm not gonna do them now because I don't feel like it. I just want to skip through this. Okay, let's take a look at this, and I'm gonna answer that question in a moment. So let's see what they're saying. Function values. Functions are values too. They can be passed around just like other values. Functions values may be used as function arguments and return values. Okay, so this is so we have a compute function here that takes basically a callback function in a way, right? Because it takes another function that that has some arguments, right? And then it returns and it calls that function. So in JavaScript, yeah, this is very common in JavaScript. The whole Node.js ecosystem is built around callback functions. So when you get an HTTP request, we call a function, injecting request and response, and next, for example, an express or whatever, right? So in this context, they're saying the same. Is like, hey, you can pass functions to other functions in Go as well as function arguments. Nothing special there. And this is basically in JavaScript, right? This would be called function expression, meaning when you create a function without using, sorry, this would be called function declaration. No, function express. So this would, in JavaScript, this would be function declaration, and function expression would be, let's say, const or var, I don't know, const x, and then you have a lambda function or just a normal named function, whatever, right? So this is, in a way, when you look at it, this example, you could think of it as a function expression as well. So we have a variable to which we then assign a function. Man, of course, man, I don't care. Of course, you can share any content you want, man. I don't. Of course, you can share anybody, man. That would be silly to. I don't care. This is not a competition, right? I stream because it's fun, not because I care about others. So yeah. So what is to say here, right? So in Go, we can pass functions as function arguments. We can create function expressions just like we can in JavaScript, meaning, you know, var this, and then I guess you say func is equal to this. Of course, this is now invalid syntax probably. Let's see, what am I doing wrong? And then we can see that the type of this essentially is this, right? So if we were to write the full kind of variable declaration here, just for the sake of being explicit and seeing what the hell is happening, you can see that, yeah, we have created some function that's of type this. So you define the function argument types and the return type, and then you say, hey, so yeah, this would be called, in JS world, a function expression, right? So there's no difference here between JS world. You can query functions, you can do whatever you want. So you can see here, again, very common, very common. This is a whole JS world is based around closures and functions like this and stuff like that, right? Ah, here we are, function closures. Beautiful. Almost as if I knew that that's coming, and I kind of felt it. Okay, so function closures, very confusing subject to some, especially in the JS world. But what is a function closure? It's just a function that closes over other function and uses the scope of that outer function, right? Which then it makes it essentially preserve the values in it, and we're gonna see that on the scope, on the stack, sorry. So we'll see about that now. So if we go into the browser a little bit and write the function, we write a closure, right? So we say function outer, and then here we return another function called inner, and then here we maybe define var x is 1, and then here in the inner function we can say x plus plus, for example, x plus equals 1, right? So now we have this outer, so we say const, I don't know, x, or we just say let x is outer, right? And then we can say x, and we can call this x several times, right? We're actually not printing anything in here. We should have probably printed something before I did this. So let's do this. Not a very nice formatted code, is it? And as you can see, as I call these functions, right, you can see that the scope, that the, Jesus Christ, man, my brain is, you can see that the state of this outer function, meaning the x, is preserved. So as you can see, as I now call x, the x is, so even though the function, the function is removed from the stack, this reference to the inner thing is keeping it alive in a way, right? So this is a low-level stuff, so let's not get into it. It doesn't matter at this point, but this is what really a closure is, and this is why JavaScript, before we got some modules and stuff, depended so much on closures, and this is also what we're talking about, closures now in Go as well, basically. So if we go to the code, that's, I believe, probably my assumption. Yeah, that's pretty much what they're doing as well. So they have a sum declared in the outer scope of the adder, and then they have an inner function that they're probably gonna call, and I'm sure they will. So let's see what they're doing here. So they declare two functions here, adder, and actually no, they call it twice. No, they actually, so we declare a function pos and neg, and then we basically pass them some values, right? So you can see that this inner thing is taking the value, and then if we actually execute this, we're gonna see that the state or the values are gonna be, that's not what I want. You can see that the values are actually preserved. So we can speak about closures probably for like 2 hours. There's a lot of stuff to be said about closures, their application, their use, their history, and how they affected the whole, at least JS community. But we're not going to do that now, because that would be a whole. We could talk about closures the whole stream pretty much. But what can we memorize for now in this session is that closures in Go work exactly the same, almost. Let's not say exactly, because that would be a vague statement that I can't support right now, but let's just say that they work very similar. So far, they work the same, but maybe there's some exceptions that we don't know. So let's be careful with words. We're not gonna do this either, so no exercises today. Maybe I can do them next stream when I actually do them, so we do it faster. And yeah, that is this 27 things that we did today. Let's see how far we got. I think so. What I will need to do, I'll need to figure out. I think it would be too much. So this approach we can't take forever. I think there's so much of this stuff that it's becoming a little bit too much, and I think it's not, if I may say, scalable in a way that people are going to get bored going this bottom-up approach. So I think maybe next time we can actually start building something, and then use the tour in a backwards way. So go from top bottom. So throw ourselves into the problem, and then use the books that we have, the tutorials. We're gonna use YouTube. We can use ChatGPT, obviously, to learn together. But we need to learn properly, so we need to kind of. So I think next stream or tomorrow, hopefully, we can start building something, and then go a little bit back and forth. Because right now, I mean, when I look at this list, it seems to be. Yeah, I mean, there's quite a lot of stuff that if we would go through this, maybe it would be just a little bit too much. It would be yeah. All right, so. Okay, so it's good. So one good thing that I saw today in the stream is that, I'm abroad. We are traveling now, so I'm not on my regular in my regular space, regular office. So I'm gonna try it. As you can see, my setup is also very different. Display. Let me enable preview. So let me do. I don't even have my OBS set up here properly. Display capture. Where is this camera? Shit, that's not what I wanted to do. So let me try to do something like this, transform, and then, where is it? Stretch to fit the screen. Oh yeah, there we go. Super. And then I can go here. Yeah. All right. So guys, let's chat a bit if you want. The stream has been 3 hours. Beautiful. So this is the second stream on Go. We started this recently. There's a previous YouTube video if you want on my YouTube channel. Feel free to take a look at it if you want. If you don't, that's also fine. And we're gonna do the same tomorrow. We're gonna be basically focusing on Go for some time. I'm actually very happy to do something different. I've been streaming the same thing for a year, just building the programming network platform. So I think I want to do something a little bit different. What did I want to say? Was the sound and quality of the video solid as it generally is? Leo and others, like, would you say that everything was fine? Because I literally bought this laptop like a week ago, just so I can have it abroad. Was everything okay? Sound was good, quality was good. Okay. Okay, good, great, awesome. Does anyone have anything to ask? Any questions? Anything that you guys wanna discuss? I mean, I'm here. I'm on vacation. So I have all the time in the world if you guys wanna discuss something. Otherwise, basically, I'm traveling now with my wife and kids. So I'm in another apartment that we own abroad. I mean, you should be well. When I hear fine is not sufficient. I mean, I want thing to be as best as it possibly can be. So I hope it's great. I would expect that the sound and video is great. The thing is, Leo, like maybe tomorrow or some other day, I really wanna do like a longest stream that I ever had, because most of my streams are like 2-3 hours. Like I wanna do like 6 hours, because now I'm on vacation, right? Yeah. All right, well, let's call it a night then, guys. It's midnight here. I've been traveling today for 12 hours. We had a long flight, and I'm exhausted. So, yeah. Thank you very much for being here. Thank you for your help with Go. We're going to continue learning this together and building things. Yeah, what is to say? Super fun. Thank you so much, everybody. I wish you guys a good evening, and my pleasure, guys. Thank you so much as well. I really appreciate every single one of you. Thank you. Many of you have been involved in the chat. Thank you very much for that. I appreciate that a lot. That's why I stream. So please keep that up. Just keep talking, keep sending messages. It's super fun to do things with community, and I really enjoy that. It's why I stream. The only reason why I stream is to build things together. Dev, thank you very much. Dev, Crude, thank you very much, man, for good points. Really nice discussion. I really enjoyed it. And Chris and everybody. Obi, thank you very much, man, for the kind words. I'll see you guys tomorrow, okay? I wish you guys all the best, and have a great one. Peace out. See you tomorrow. Bye-bye. Cheers. Bye.